Neuro Hallucinations V1 with Daniel Escobar, um, which is going to be using Google Colab and Blender and Unreal Engine to create these interesting, um, in my opinion, hallucination kind of spaces with AI and all that. So I'll introduce Daniel, who is the founder of Diffusion Architecture and co-founder at OLA. And Daniel is a creative designer and 3D generative AI researcher, passionate about pushing the boundaries of creative workflows and enhancing the creative process. His primary focus lies in exploring creative applications for 3D generative neural networks. He co-founded the practice OLA, which focuses on developing projects through a variety of media, including architecture. He has been published at Cadria, Acadia, ArcDaily, Dzine, and taught a variety of workshops exploring the intersection of AI in the creative applications. He also founded Diffusion Architecture, a platform recording and disseminating creative use of AI in architecture and design. So welcome, Daniel. And before you jump into it, just want to mention for everyone here, if you're chatting in the chat, make sure you switch the chat to everyone. Same for you, Daniel. We all seem to forget that one. I forget it all the time. Zoom likes to trick us up with that one. And if you have questions, please use the Q&A button. It's easier to keep track of. If you see where all your buttons are, like sharing reactions and all that, there's one that's called Q&A. So you can ask questions there. It's easier because it won't get lost in the chat. Just to remind everyone that this webinar is recorded and you will get access to this recording after the webinar. It will be emailed to you. Usually can take up to a day. Depends how long Zoom takes to process the recording. And just another reminder that not everyone learns at the same pace. So if you feel you can't keep up live, just, kind of watch and, you can check the recording later, but we do have to get through the information. Also, just a side disclaimer that this webinar is using AI and a lot of these tools are experimental and process heavy. So there could be moments of crashes and freezes and lags. But that is to be expected and all normal in this kind of workflow. Had to throw that one out there for you, Daniel.
Yeah, no problem. Thank you.
Yeah, so we can get started with you if you want to start by sharing your screen, and I'll be here in the background.
Okay, sure. All right. So I'll start sharing my screen. Oh, Michael, can you enable me to share?
Yeah, sure. Should be. If you can try again.
Yeah, okay. So looks like it's working. Okay.
Cool. Yep,
Cool.
I see it.
All right, sounds good. All right, so I'll get started. Thank you, Michael, for that intro, and thank you very much for inviting me to do this workshop. It's an honor, and thank you everybody who joined. Hopefully, I mean, it is jam-packed. There's a lot of things that we're gonna go through, and I'll go quick over some of those things. Let me just share here. Okay. So this is gonna be as it called neural hallucinations. So it's gonna be about generative 3D AI. So we're gonna be using a generative 3D algorithm that can generate let's say a space based on using cameras, a stable diffusion model, and then some depth projections. And then it's gonna output like a mesh. And I'll show you guys what the output is in a minute. But the main idea is to be able to test out how these algorithms work. And I'll show a little bit about kind of like what is like the approaches being used in AI to be able to generate 3D spaces using like images, essentially, and how there's like some tricks related to cameras to be able to match let's say, projections of images into 3D space and join them together. The algorithm that we'll be using can output a 3D mesh. That's why I picked it. So it'll be easier to use and manipulate using it in Blender and in Unreal Engine. So the first part would be to set up a Colab, and I'll show you how to do that. And it's pretty much like setting up the Colab, loading it. We're gonna save it to your Google Drive, and then we're gonna set it up. So then I can show you how to edit it with prompts, and then add some text so you can generate like a 3D mesh. And then we can start the generation. This is gonna output some video animations, and then export a mesh output that we can use later on. And the main idea behind this is that you'll be able to start from like a starting image, and that image would have like a prompt that you can like change. And then from there, the algorithm is gonna try to like piece together a 3D mesh out of it. Let me see if I forget. Okay, so also if you haven't used Colab before, there's gonna be like two parts to it. One of it is that Colab is useful because it's like kind of like being able to do code online. But they also give you like some free GPUs. And with this algorithm, you can use the free GPUs, but it usually takes a little bit of time to run. So if you can subscribe and get like the pro version, which could be like $10 a month, and they'll give you like some compute GPU units. Or you can get like the most advanced version, which would give you more GPU units, which costs about like $50 a month. They give you about 500 GPU units. I think for this part, the free version should be enough. But if you want to like have the algorithm running faster, then definitely would recommend getting like the pro version. Okay. So first is going to be Colab, and then we're going to go into Blender. And Blender, I'm going to use it mostly as a kind of post-processing of the mesh, because we have to get whatever the output mesh comes out of the algorithm, and then do some shading, UV texture, and then saving those UV textures out as a PNG, and then exporting as an FBX with the UV texture, so we can use it in Unreal Engine and visualize it. And then Unreal Engine is going to be essentially to set up the scene, import the mesh, set the texture materials, some lighting, collisions, and using Niagara to generate animations of like the particle systems. And then we'll end with that. So that should take a little bit of time, and we'll have some breaks in between. Okay. Cool. So that's the first part. I'll share a little bit. Let's see if I can get this here. Okay, so a little bit about myself. I have done like previous work and research into using machine learning and to generate like 3D structures and so on. So I've explored, sorry. Okay, so I explore essentially using 3D reinforcement learning. Okay. I use 3D reinforcement learning to generate aggregations of like systems. Essentially, this is like this line at the top here. And to be able to generate these aggregations using like a certain rule. So I have the algorithm learn those rules and then be able to replicate the forms by using those rules that I learned. Some other things are related to that, these kind of like aggregation modules here, related to like drones, and then some other more speculative works that combine the use of machine learning to generate more free-form 3D structures with the combination of some biodigital algorithms. And this was done with OLA, which stands for Online Lab of Architecture, and it was formed by myself and 4 other people that are all architects and designers. And then alongside that, I've been doing also research and exploring the idea of how do you take images into 3D models. And these are like some of the explorations that I've done related to like occupancy field nets, sign distance functions. And then so how do you take an image and then predict like a 3D model out of it. So that's kind of been more of my interest in recently, and how do you use that to generate some sort of architectural space. Okay. Okay, and then I'm just gonna do like a quick presentation about what is kind of like this field of 3D generative AI, and some of the things and like it's like tricks and strategies that have been deployed to be able to generate some of these 3D objects from like a set of images. So this is the main part about this is that it's called neuroviolent rendering. The main idea behind this is that you are going to essentially create like some sort of bounding area, some like field, and then you're going to project images into that field. And there's like a variety of algorithms, but it's a type of representation that allows you to generate like 3D objects from like a set of images, similar to like photogrammetry. Um, but in this way, you would do it through like neural networks. And the 3D generative part about this is that you're going to use, or like some strategies are going to use methods like, they're going to use methods where they can take like a stable diffusion pre-trained model. And if you guys don't know what stable diffusion is like a text to image generator. You probably might have heard of it, or like you heard of Midjourney. They work similar. So you can use one of these text to image models and then use that to essentially generate like an image and then slowly stitch it together to generate like a novel 3D object based on those images and prompts. The images that I'm showing here is like based on a method that is called like Gaussian supply, which is like a little bit more recent. And essentially it works by generating like a set of like point clouds, and then those point clouds have like certain parameters that distort them. And then that matches up with the colors. So eventually you get to like some of this image kind of like at the bottom where it has more of like the texture and the colors of like the original image. Okay. So geometric representation. So like one of the big like issues, and if you guys are in architecture or like done 3D work and any 3D software, you're probably familiar with these representations. Most commonly is like the mesh, point clouds, um, and then you have others like voxels and octrees. So one of the main issues in 3D generative AI is like which one is the like best representation to represent like a 3D object essentially. And that comes down to like you know, what is like the input that you want to use, or what is like the most efficient way to process geometry or generate it in some manner using like neural networks. So you have to like tailor kind of like the use of the neural network and the geometry representation to be able to like learn on it. Sometimes there's like issues with like, you know, each of these kind of like representations. Point clouds are sparse. They don't have any like connectivity, as you can see. Meshes kind of like improve on that. So they have some connectivity, but meshes are usually a little bit more uh wildly to like manage, because like they're connected. So if you push something, it's gonna like move some things, and then they can have like intersections and so on and so forth. So that's kind of like one of the main issues. Graphs is more related to mesh. It works like similar approach. And then the other one, which is like more volumetric, is the voxels, right? So it's kind of like taking a 3D object. It could be a point cloud or a mesh, and then generating a voxel field and populating that voxel field on that geometry. Um, and then the other ones that are a little bit more interesting are kind of like these RGBD, which is like the image data. So like RGB, like the pixel colors, and then like you have depth data. And usually the depth data, it's either like you get it from some ground truth I don't know, data set, like you can generate like from like a game engine or from like Blender and spit out like the RGB image and the depth map, or you can use like a depth predictor neural net. So you can also use that and then combine them, and like using these two, you can apply it to this multi-view representation. where you can have the image and the depth map project into 3D space, and you can generate like a 3D object. And this seems to be like the most common view to be using with some of these 3D backbones, like kind of like the Gaussian splat, the NERF, if you're not familiar with NERF, and somebody wrote about Luma AI. Yes, like they use like NERF and Gaussian splat. Um, so like that, you feed it like a set of images, and then it's gonna like kind of triangulate based on like poses of these images, and it's gonna project those images into like a 3D field. And once you have that, then you get like a 3D object, and essentially you can take that 3D object, convert it either into a point cloud or a mesh. The issue with that is that sometimes those objects or like those conversions, they don't come out as clean. So there has to be like some refinement process after for like the mesh. Okay, so that's kind of like the main overview of like geometric representation, which is like super important in like machine learning. And it's like a topic that is constantly being explored. And then like we're more familiar, like architects or designers with like using meshes and stuff like that. But if you want to work with like AI, you have to kind of know and understand these types of representations and which one serves like your use. Okay. So there's like one more interesting like aspect about this that I was mentioning before, which is like the multi-view. So you need to use neural rendering, which is like a process that uses a neural network to like project these images and learn essentially those representation using like weights. So it's going to learn like these kind of parameters, and then from there you can then predict whether this 3D object exists in 3D space. And then these are some of like the properties that you need to understand uh, essentially when you work with these types of data sets. So like illumination, camera parameters, and the camera parameters are like your camera intrinsics and extrinsics. So like your camera pose, and then like the dimensions of like the camera. So like if it's wide angle lens, what is like the depth of the lens, and so on and so forth. And then geometry, like I was mentioning before, and then appearance and semantic structures. And semantic structures is more related to how you want to parse essentially like the image or the 3D structure. So if there is parts that, for example, if you have, let me see, if you have, for example, this guy here, and you see like its color in different areas. So like if you want to essentially filter out like the arms, the legs, so how do you get that semantic information? And that there's like several like AI methods to do that now, but that's kind of like another part that goes into this. Okay. Um, So this is kind of like how it works here in this animation. And the main idea works like it works like rendering. So you're gonna like project rays into a scene, and those rays are gonna come back, and they get composited into an image. And the way that essentially this works is that you can take like then a neural network, like a multi-layer perceptron, and then that would be able to estimate the coordinates of that ray, and then like the color and the density, and the density is usually related to like a nerve, where like it means like whether that space in that like that box or like that 3D box field is occupied or not. And that would tell you like, if that color is in that space, okay, and it's occupied, then project it back into the image, and then you get, like this color guy from this angle. Um, And then there's some methods that are called like implicit representations. And some of the ideas behind this is that instead of like inputting like a mesh or like, any other representation to learn from directly, you're going to generate like a field of points, like random points. And you're going to take samples, and then your object here, which is like a chair, kind of like lives in that field. And you're going to tell like the neural network to essentially predict from like a random set of points where these points are occupied by the object or not. By doing that, then you don't necessarily need the 3D geometry. You just need to know or like the network learns to predict which point is occupied or not, and that should give you like the 3D representation. So this is kind of like the example for this. This was like based on a project that I worked on where we were exploring how to generate these fields from like an image and how to predict objects in 3D from that. And this is kind of like one of the basics or like one of the most standard models that came out during this time, which was about 2019, which is called an occupancy network. And this is like an implicit way of representing a 3D object in space. So you would have essentially this point clouds here, and then you're going to predict a binary occupancy, which just means like if the point is occupied or not, and that should give you like the 3D representation of that mesh. And then you can take that 3D point cloud and then do like a post-processing step and get like a mesh out of it. Okay. And then there's some other methods that involve that. So like once you learn kind of like this implicit shape, you can use it like in autoencoding, which is kind of like building reconstructions of these things, or shape generation, or single view reconstruction. And essentially you can then build a latent space. And if you guys are not familiar with a latent space, it just means kind of like a learned space where the neural network projects into lower dimensions all the information that it has compressed by learning all these shapes. And then you can interpolate through that and have these kind of like interpolations to the 3D objects. So that's like really useful. And you can kind of, if you're familiar with like StyleGAN, like like Rafik Anadol videos, he uses the StyleGAN in this manner, but for 2D images. And here you can do it for like 3D images or 3D objects, I mean. And this is another type of representation, separate like the point cloud. This one is essentially trying to like map an edge line of the object, where essentially it's called a sign distance field. What that means is that that edge line around the object represents like a zero. So like if you're on the edge line, it's a zero. If you are outside of that object, then it's plus, it goes in the +1, +2 direction. And if you're inside, then it's in the negative direction. So that's like a way to kind of like estimate the normals of the surface, and it tells you whether something is inside or outside. But it also tells you kind of like where the boundary is. And you can teach a neural network to like learn that boundary essentially. And it's an implicit representation because it doesn't have the geometry. It just has kind of like these regions or like these areas where you have certain values between 1 and -1, and then 0 is like where that edge should be. Okay, so this is similar. This is kind of like, this is another method that came out a bit ago. But the idea here is like to be able to learn 3D representations of bodies from images and be able to generate the reconstructed geometry of people. So they use kind of like the methods that I just spoke about, where you take an image, project it out in space, and it's going to generate this occupancy field. And from there, you can get the geometry and then the texture reconstruction. So that's kind of like one of the, let's say, applications from the previous methods. Okay, so I kind of already talked about this, but this is like a really nice diagram to just show how the neural network works. So you take multi-view images of like the person, you encode it through like some neural network, and then that neural network is gonna like create this field, and it's gonna project those images into that field, and then it's gonna try to reconstruct the original image by essentially measuring the distance between the original image and the reconstruction image. And that's how you would train like a neural network of this type, which is, it's essentially like a nerve, or like a lot of these kind of neural networks, like a Gaussian splat. They use a similar approach, except you just change maybe like the neural network architecture. Okay, so like the most famous one, if you guys probably heard about it, and if you use like Luma AI, it's Nerve. And that's kind of what Nerve does. It takes the images, projects them into 3D space, and then it's able to generate kind of like these 3D objects. The only issue with Nerve is that the original one was like very expensive in computation. And it also has some issues where it is able to interpolate between unseen areas, but it's not able to predict those unseen areas. So you might have like some weird cloudy artifacts. So you can kind of like see here like the 3D recreation of objects or scenes. And essentially, you don't need 3D geometry. You don't need a mesh. You kind of just need like this set of images and their pair camera poses, and then it's able to generate like this scene representation. And then what you can do to generate like a video or like an image is that you can just feed it like the camera pose to the neural network, and the neural network, since it learned like what that camera pose might be looking at, it can then predict what that image from the camera pose would look like. And you can kind of like see here like the process of how this ray gets composited back into the image. And then you have the 3D scene. And then you can take that and then use like point clouds or transfer it to point clouds and meshes, but then you have to like do a post-processing. Right. Okay, yeah, so that's that. Difference between neural learning and photogrammetry. So photogrammetry uses triangular matching of image features, and it does not allow for interpolation in non-captured spaces. Ideally, the neural network should be able to like kind of fill in those gaps. And that's kind of like an interesting approach where these 3D generative AI networks work, is that essentially you can start from like, let's say image one, and then you're going to move your camera and then try to patch that missing gap here, using like a stable diffusion or an in-paint thin diffusion model. Okay. So yeah, the problem is like the camera poses. So you need to have essentially a way to estimate camera poses if you're gonna do like a scene reconstruction. The good thing about like doing a 3D, like a 3D generation without the need of camera poses is that you can generate the 3D camera poses, and then just project from those. But then you would need to be able to know how to generate those poses, so they're useful. Um, and it's a process that is currently under research. So people are trying to figure out how do we like figure out how to estimate the pose and the image, or like how to reconstruct the image. Let me see this. So this is kind of what it does, right? Like, so you have like round tube camera poses, and you're trying to estimate some poses based on those ground truths and the image. So it's like it should be like a joint process, but currently some of these methods don't work as well in real life. Okay, I'm not gonna talk about that. Okay. Okay, and then there is some methods that propose post estimation. This was one of them. It's called BARP, and then minus minus. There's some newer ones, but the idea is like you're gonna like learn the view rendering and the depth, and then try to use that to triangulate or estimate the camera poses on the image, and then until you finally got the image or the ground truth image to match as much as possible. Okay. Okay, and these are some other methods like that they're trying to also estimate the pose and the reconstruction. This one's called FlowCam, which is kind of like projects the camera and then it's trying to use a flow map or like a flow projection network that can predict if the camera moves where the object might go. And then based on that, they can estimate the camera poses. And then another network that took this a little bit further, also using stable diffusion, is that it's called 0, 1, 2, 3. And the main idea here is that you can take, any image, start from like an image, and you want to try to predict the other angle of that image. So essentially, you're gonna move the camera, let's say, For example, here, you're going to move like your original camera from the original image, like down 30 degrees and left 30 degrees. And then that should be able to give you like a new view. In Stable Diffusion, or the model that was tuned for this, should be able to predict that angle. So this method kind of worked well, and there's been improvements on top of this, but this was one of the first ones that showed that you can essentially use one of these text to image models, fine tune them for like the view angles, and be able to generate view angles for like an image. So this works, and you can use this now to like create like a 3D reconstruction of like an image or a generated image. Okay, and then these are just some other methods that use different types of um, architectures for like the neural networks, like TensorRF. They kind of use this interpolation grid, so they generate kind of like let's say some planes in this 3D field, and then by that you can like kind of index into those planes, and then that would give you like what is the prediction here. And then NGP, which Instant NGP, if you guys are not familiar, it was kind of made famous last year by NVIDIA because it was made, it made nerves able to reconstruct scenes fairly fast. And NVIDIA has like a viewer that you can download and play around with. And then Planoxels is like another approach, which is kind of like spheres, and these spheres have a certain property that's called spherical harmonics, and they can sort of determine the viewing color from like all directions. And once you pair them together, then you're able to learn, those colors and views, and then that would give you like another representation. Okay, and I don't have to go over that. And this is kind of like the trend here. This was posted by John Barron, which he's a researcher into these methods. He developed the NERV method. And you can kind of like see we're at this point where like we're sort of slowly improving the quality. SIP-NERV had achieved like the highest quality, but then 3D Gaussian Splat is like a nice trade-off in between that was released this last year. And it's also improving the quality and the speed. So there's constantly updates into these methods, and they can be applied, I guess, like to generative methods as well. Okay. And then these are the generative methods. So these is where these methods get combined with image generation or like any image. One of them is called like pixel nerve. Essentially what it does is that it takes it can generalize across images per scene. So one thing I forgot to mention is that for the original nerve in these kind of like reconstruction models is that you can only train them for one scene. So you wouldn't be able to you wouldn't be able to essentially use them for any other unseen scenes or images that they weren't trained on, which that was kind of like one of the biggest held backs because it wasn't worth it to train so much on one scene and then not be able to use it for other things. But this method, Pixel Nerve, attempts to solve that. They try to feed multiple scenes into it and learn multiple scenes. And then you can feed any image, and then it would try its best to complete the scene from any image that it was trained on. So it doesn't rely on just one scene. In this one, Laser uses latent VAE, which is a variation autoencoder. So ideally, it's just gonna like try to like learn various scenes. So you're gonna feed it multiple scenes, and it's gonna try to reconstruct them every time. So by trying to reconstruct multiple scenes, the neural network should be able to learn how to reconstruct like multiple scenes. This is what some of the work that I've done with some colleagues. And the idea here is like we were exploring how to use like an image and then convert it into voxels. So like one of the main issues here is that essentially if it hasn't seen in a data set outside of that representation, then it's gonna have a hard time trying to like predict these elements. So for here, like we train in a specific data set and then input like these kind of like new images. So some of them work well, like you can kind of like see, and some of them don't because it's never seen them. Also, it has to do a lot with like the type of views that it's seen. So usually like the mask areas work really well or decently. The other ones that have like more texture in the background, they kind of get a little bit lost. So like the concept or like the one of the main issues in these kind of process is that if you're gonna use like images from reconstruction, it also depends a lot on how you like kind of like structure these images. So one of the problems in AI in generative AI is like how do we go beyond this and generalize to a lot of scenes? And I think like the image generators kind of like help in that way. And this was Dream Fusion, which was one of like the first papers that was able to generate 3D objects in a consistent manner using Nerve as kind of like the scene representation. And then it was able to return these 3D objects generated from text with texture on them. And this is Magic 3D. This is a work by NVIDIA, but it uses kind of like all those previous concepts. And it uses the instant NGP, which is a fast nerve type representation. And the main idea is that you're going to take an image, you have the camera, which matches the image. You're going to use like a diffusion model, so like stable diffusion, let's say. It's going to generate some sort of image render from this 3D space. And then you're going to try to lower the difference between the two images, between the original image and this generated 3D object image. So you do this in one process, and then to texturize it, you reproject that out and fine tune the image so it goes to higher resolution, and then you finally get this kind of higher resolution mesh with texture. So this is kind of like a lot of these let's say 3D generated models work, where they can take initial 3D representation like a nerve, use a stable diffusion model, create the 3D space based on that, and then fine tune it or go to like a high resolution optimization to get like a nice quality texture on top. Okay. And then I'll just show, these are kind of like the ones that are a little bit taking some of these scene reconstruction methods into 4D or like in time. So this is kind of like a video, and now you can essentially see the scene in 3D, but with animation. So that's really cool. And I think there's been a lot of work now at exploring this. And then this paper here, it kind of introduces that process of like stitching together images in 3D space. And this is going to be the method that we're going to be using for today. It's called text to room. There's actually like a link here for the paper if you want to read that. But the main idea is that you're going to manipulate the camera. So you have to like apply some camera manipulation tricks to be able to find camera locations within a scene, and then slowly start from like a single image and start stitching it together to generate like the scene. And then the final output is going to be a mesh that gets cleaned up. But this uses two parts. It uses like the original generated image, so text to image, and then it's going to use inpainting. And then at the same time, you're going to use another neural network that is going to project a depth map based on this original image. And then you're going to do some depth alignment. So like where there's edges between these kind of like 3D mesh projections, you have to figure out a way to align those edges because sometimes the depth maps are inconsistent. And then once you do that, then you clean up the mesh, join it, and then you have like a final mesh output. Okay, and then this is just a little bit extra, but it's kind of cool, where you can take like the image, you can run something like Clip, and if you're not familiar with Clip, it's one of these models that essentially can learn, it learned text and image as pairs, so it can understand like textual description of images. And the way that they're showing it here, how you can use it in these 3D models is that you can use the clip feature, so you can tell it, okay, find me like the base in the 3D scene, and it's able to like extract that information here. So it's able to like map that prediction here in 3D space. And essentially, this is really cool. This is kind of like where things get interesting because now you can apply all these pre-trained networks, let's say by OpenAI or Meta, and be able to extract 3D semantic features from like 3D scenes. And what's cool about this is that it doesn't use the 3D scene. Essentially, it just uses images. So it's projecting from like an image into the 3D scene. And then another one is like editing. So how do we use these 3D models to like edit scenes? Climate Nerve is like one of these approaches where like they take an original scene from multi-image, they train a nerve reconstruction, they get a style image, and then they're able to essentially how you say like reconstruct the scene, but with the style image. So they can like modify so it represents like different climates. So in this case, like snow. And this is really cool. I think this is kind of like where things are going now, where you want to be able to edit these kind of like 3D representations via some style images or text. Um, uh, okay, and then I'll just close up with these last papers, which is like a combination of all the methods that we saw. So currently with AI, there's like a lot of fusion occurring where you have a lot of kind of like these large pre-trained models, let's say from OpenAI, Meta, which they can also generate audio or they could generate like clip features or any other sort of thing that allows you to like segment and extract information from like images. So how do you apply that then now to like a real 3D scene and start parsing the scene in such a way that it can be used in robotics or any sort of kind of like automatic navigation tool for robotics. So you can give instructions using like a large language model or so to like a robot to tell it like go to the table near this image, and then the robot is gonna like understand the scene using all these previous methods that I showed and be able to find the scene. So this is really interesting, and like this is kind of like an area that is becoming really worked on in research now, because in robotics we can apply these methods. So people are trying to figure out how do we apply them and get like cheaper robotic training essentially that can be used in the real world. And then this method here is like kind of really interesting because it combines like a layout, but then from this layout, it can generate like the 3D objects. Um, so like the key idea behind this, okay, is like you can generate like the 3D scenes, but can you condition it on a layout? So like given this kind of like layout here with the objects and their segmented kind of like colors, can you generate like a 3D scene out of it? And this uses also depth maps out of it, so it's able to like make sure that the scene is accurate. So this is like a really cool method, and it's interesting to be able to combine these two. So it's not just kind of like a text generator or any other trick. And this is like a similar method to that one, except here you're kind of like given this like bounding boxes where let's say like a nerve model and like a image generator model would take those bounding boxes and like essentially um, generate a scene based on what you tell it for those bounding boxes. So it's more compositionally driven. So this is really cool too. And then finally, like I was saying, for robot learning, we need to be able to have these kind of like neural fields to understand the scene in ways that if you give instructions to like a robot by using text or a large language model, can translate that into a 3D action. So this is really cool too. Okay, and that was that. Um, so now let's move on to the Colab. Okay. Right, give me 1 second. Okay, so I'm gonna show now like what is like the final output that we're gonna get to in Unreal Engine. I'm just gonna reshare my screen. And then we'll get started with the Colab. Okay, questions. Does anybody have any questions? Aaron Aiden said, is Gaussian splatting method also something similar? Yes, Gaussian splatting is similar to like a nerf, except that the way that that is initialized, so like the way that you train it, it uses like point clouds as a starting point. And that's kind of like the main difference between like the nerf. So by using point clouds as a starting point, you kind of lower the cost of computation. So it makes it faster, and it also has like some tricks for representing color and opacity and space that are constrained to those point clouds. So it results in like lower memory computation. But yeah, it is similar. That I think Gaussian splat is kind of like the method right now that is most efficient, and is currently being used by Luma AI. Yes, I will be sharing the webinar files in a second. Have you ever used Runway to animate? When you mean animate, you mean like the text to video or something? And yes, yeah, I we used the text to video before. And there was actually like a paper that I wrote with two other buddies of mine, George Guida and Carlos Navarro, where we actually tried to modify existing scenes using image-based models that can remap, let's say, like a video that you feed it. So it's kind of like you can give it a text and then like change how the video looks, and then take that video and send it to like a Gaussian splat and recreate the scene based on the modified video. So yeah, it's really cool. Um, okay. Are there neural networks for 3D generation that are trained to create 3D objects based on a sort of understanding of basic geometry? Theodora, so I'm guessing you're asking if like if it's gonna extrude. So like there is 3D generation networks that can generate parts like that, but it doesn't know like that it needs to extrude it. How do I say this? Like all it's doing essentially is like, for example, I mean, I guess I can show this real quick. Let me say, yeah, Gaussian splat. Yeah, that's correct. Gaussian splat is a 3D reconstruction method similar to like a neural radius field, like a nerf. Um, so- okay, look. So, Theodora, I don't know if this is what you mean, but this is kind of like the closest thing that I can think of where like it generates like a mesh like triangle by triangle. It's called Mesh GPT. Essentially it's kind of like building out the 3D object. The only issue with this is that you have to like train it, but it doesn't know like, oh, I need like like I need, let's say, like a leg or something like that. It doesn't know that. It's just trying to like build the object based on what is seen and like on the probability. Right. Yeah, 3D Gaussian splat. Let me see if I can. This is like the 3D Gaussian splatting. So what it's able to do, it's able to reconstruct like a scene. I don't know if I have a good video here. Uh, Might be sharing too much stuff right now. But my computer's lagging a bit. So it's able to reconstruct like a scene based on like images, but it just uses like a different representation. So you can kind of like see here. Like this is actually like a reconstruction. This is like a rendering. This is not like a video. So it's pretty good, and it does it very fast. Okay. Oh, I'm sorry. 1 second. Okay, I don't know if you guys see this now. So this is for Theodora. This is like a mesh object generator. It's called Mesh GPT, and it generates like a mesh based on like the triangles. So it's kind of like builds slowly the mesh. But it doesn't know like this is a leg, so you have to extrude a leg. I don't think we're there yet. That's the neural networks still can't do that yet. Um, yeah, so you get like these mesh outputs. And then what I was showing is the 3D Gaussian splat. Uh, which is this here. So you can kind of like see this is like not a video. This is actually like a rendering from like a Gaussian splat. So like they placed the camera and they told the camera to essentially render what it learned from reconstruction of the scene with the neural network. So it's really cool and it's like really fast and it has like pretty high quality too. So it's definitely like a good. It's so good that like Luma AI is using it now for like their main reconstruction engine. Right. Let me see if there's more questions. Yeah, Polycam also. Yeah, exactly. Okay, cool. All right, so I'm gonna go to Unreal now and just show kind of like the final output, and then we'll get started with the Colab, and I'll send everybody a link to the workshop files. Okay, so I should be sharing the Unreal screen right now. Okay, and then I'll just show real quick what does the mesh look like. So this is the output that you would get from this model, this AI model, which essentially is like a mesh reconstruction. Um, and this is all like AI generated. So like it does some things all right, some other things not so good. Like you can kind of like see some of the issues. Oops, I think this might be a little bit too heavy now. I'm looking through it. Give me 1 second. I just want to close some things out. Okay. So you can kind of like see like it's all right. It is a mesh representation, so there's some weird things or like weird artifacts that happen because it uses a depth projection network. So what ends up happening is like sometimes it's not coherent, like this kind of like breakdown here. And that's kind of like the issue with like the way the depth projector works, and then also how you kind of like stitch the images together. Um, because the cameras that are being used to project these images into 3D space, sometimes they don't align. They don't have like understanding of the overall scene. So there's kind of like issue with coherence sometimes. Um, and then a lot of this is kind of like in-painted. So it would start from like this original image, and then it'll slowly move its way around and start to like create this sort of wrapper around the space and project the images out. And then slowly it generates this. So this is kind of like one of the issues with the depth map. Why you would need like a depth alignment network, and like sometimes it works, sometimes it doesn't. But you have kind of like it does capture this kind of uh counter, all right. But like over here, it seems like there was like a image that was in painted where like it slipped or like it slid the counter a little bit away. So like the depth projection map didn't project it or align it correctly. So that's kind of like one of the issues with this type of approach. But it's still pretty decent. It's still able to generate like some space. So I thought it was pretty cool. There's methods that are evolving where they don't necessarily use the mesh, but I think with time this would essentially get better. And this is kind of like the mesh output. So now if I go to play, so you will have this player, and then once the player walks into the box, you will be able to populate particles based on that original mesh. So this actually dependent on your GPU or your computer hardware. You might have to decrease the number of particles because I might have to decrease it too because I'm sharing, but it is a little bit heavy on the computer, but it does work really nice. So this is what we're going to end up doing in Unreal Engine. Okay. Okay, cool. So I'll send out now. I'm gonna share here in the chat. What GPU particle count settings are you using? So the computer that I'm using right now is RTX like 4080. And the particle count settings, I think I couldn't go past like 1 million particle burst. Otherwise my computer starts lagging a lot. So I try to do like 100,000 or like 200,000, but that would depend a lot on your computer. Okay. So
Hey,
here in the chat,
hey Daniel, I just want did you check the questions in Q&A? I just want to make sure that they don't get missed also. There's a few questions.
yeah, I only saw two. I think
Okay.
TUTOR and Aaron. Yeah, so I
Okay.
think I
Okay.
answered them. Yeah.
All right. Cool.
All right. So I'm sharing a Google Drive link where you would find the workshop files. Um, so you'll see there is, let me see if I can put it here. Uh, you should be able to access this folder. It's called Workshop Neural Hallucinations. So you would have, oh, okay, give me 1 second. Oh, okay. All right, sorry about that. Let me resend it again. Okay, let me know if that works. Okay, cool. Okay, so in this folder, Workshop Neural Hallucinations, you would have the AI output, which is kind of like what we would get, like this fuse mesh from the algorithm. And then you would have your fuse mesh output, and then several generations of the process. So you can like open them up later. And then we're going to be using after generation point Poisson mesh lab dev. So this is kind of like the final fuse mesh output, which is like clean. And then you would also find inside of Unreal files, the zip file of like the project that I have open for Unreal. And then under Blender files, you also have the Blender file with the fuse mesh, and then like a texture uh, image, and then the FBX file that I used in Unreal Engine. So those should be all there. Okay. So now let me go to Colab. Okay, so now we're gonna go to Colab. And I'm gonna show you how to upload it. So I already have it set up here. I have already opened like the file, but the way that you can open it is if you type in, or if you haven't used Colab before, but you can just type in like, I don't know, Colab research or whatever. Yeah, collabresearch.google.com, and it should give you like a basic Colab. And then what we're gonna do is we're gonna go to GitHub here. And then I'm gonna give you the link to open it. So I uploaded this onto my GitHub, so you can use it. Essentially, it's this one here. And then this link here, and I copy it here in the chat, so everybody has it. And you can copy this link in here in this Colab, where it says Open Notebook, GitHub, and then enter GitHub URL. Okay, so copy it, and then search, and then it should take you there, and then it automatically will find the notebook here. And then you can just click on that, and then it should open up a new Colab notebook. Okay. Okay. So once you have that open, so there's like, I just want to show a little bit of things if you haven't used Colab before. So over here on the left side where it says like CO Pro, I have the paid version, so I get like I have like compute units. And then you can connect by clicking this here. I actually should have done something first. So let me cancel that. So if you haven't used Colab, so what ends up happening is like what we're gonna do is we can either save it onto your Google Drive. So when you open this, you can do copy to drive here. And it should save like a copy onto your Google Drive. So like a new window is gonna pop out. That way you can have it in your Google Drive and use it later on. So I'm opening that now so we can go through the process. Okay, now you should see like copy of Colab text to room, right? So like this is your copy essentially. It's been saved into your Google Drive, and you can like search it and find it in there. The other important thing is like on the left side here, you have this panel, which is your file. So we don't have anything yet. We don't have our Google Drive connected yet because we haven't started, but you would find it here. And then this is just related. This tab here is like your table of contents. So this is related to your notebook. So you can like kind of click on it and it'll take you there, here, and take you there. Release, reshot, get in the GitHub notebook to call at. Can you write that again? Or please, you mean like redo the get in the GitHub notebook? Okay. So if you go to, when you open up a brand new Colab, if you can go to File here, and then you can go to Open Notebook, and then you can go to GitHub, and then you're just gonna copy the link that I sent in the chat here, and then press enter, and then it should pop up with the notebook here. And then you just click on it and it's gonna open it up in like in this tab. Uh, is it not working for you guys? I don't think you need to be signed in. Yeah, I don't think you need to be signed in. It is public. Oh, I don't know. Uh, okay. Well, yeah, it should be public, so you should be able to like just click on it and it should open it. Okay, yeah, so once you do that, then you get the notebook, and you should be good. And then what I would recommend is that you would go to I think file and then save a copy in Drive. So you have it in your Google Drive. So you don't have to go through like the loading process again later on. And then it should open up a new notebook that says copy or Colab, da da da. And then you can use that one. Okay. And let me switch this. Okay, cool. So this is the Colab notebook, and I'm gonna go through it a bit. Okay. So like I was saying before, if you're able to get Colab Pro, then you get more compy units and you get access to better GPUs. Well, it's fine. So we can run it like this. And then the other thing to keep in mind is that if you go here to runtime, you can go to change runtime. And then over here, you have like your GPUs that you can use. So T4 GPU is the free the free version. So this is like it runs a little bit slower. V100, A100. A100 is like the best one that is available from Colab Pro. And then V100 is like the next best thing. And then what I would do is like if you're able to get V100, hit that, and then you can also get high RAM. So memory is larger, and then you can hit save. And once you do that, then we can connect. So what we can do is like hit the first button here where it says connect using Google Drive. Because we're gonna be saving all the output into your Google Drive, so you'll be able to access it later on. If you save output into just like the Colab virtual environment, it deletes once the notebook closes. Okay, and then once you get in here, it's gonna pop out this window. So you're just gonna hit connect to your whatever Gmail account you're using, and you're gonna hit continue, authorize, connect. Okay, and then it should be able to connect. Okay, so now that it connected, you can see here mounted at content drive, right? So like your Google Drive is now mounted into this notebook. And if you if you go to this folder tab here and you hit refresh, you can kind of like see now that it says drive. And this is your Google Drive, so everything's connected here. And then you have like all your folders from your Google Drive. Okay, so next thing we're gonna go through is the installation process. So I'm just gonna like explain this a bit. You can probably just hit play and it should be able to install everything. But one of the key things is that it's gonna check in your Google Drive to see if you already have this repo installed and downloaded. And it's gonna download it, extract everything, and then it's gonna download some key weight files for like the depth projection and the normal projection networks. And then it's gonna go install all the dependencies related to Colab. It's gonna go through that and install PyTorch 3D, which we'd be using. And then that would be it. So this process, depending on your internet and where you are, it might take a bit. So I'm just gonna go ahead and like by closing this cell, if you click on this arrow here, you can just open it by having it click down and close it. And then you can just, when you close it, you can just hit the play button and then it should start automatically running the installation. So you can kind of like see it's going there, starting to download files. Then it's going to go, installing requirements, installing all the dependencies. Okay, so this takes a little bit of time. If anybody has any questions, like feel free to just leave it in the chat. Okay, so yeah, it's gonna go install, it's gonna do all that, and then essentially what we're gonna do is we can do two things. We can upload an image to start. So we can start from an image. This is an image from Will Garner. He let me borrow this. It's a really nice mid-journey image. And one of the so this is to test out how the image generator models work. But one of the issues with like using this method is that you have to match the text to be able to map this. And since it's like mid-journey, it's really high quality in comparison to like the stable diffusion models. So sometimes like the quality might not match. So there might be a little bit of discrepancy, but it's an option to have. The model that I use for Unreal is based on the following generation, which is create a scene from another room type. And I'll show you how to find these JSON files so you can like use them and modify them to generate the 3D. This one doesn't use a starting image. It's just gonna like generate its own image based on like a text prompt. Um, and it's gonna have more similar quality because it's gonna be all from the same image generator. So there's not gonna be any like weird patches. And it's gonna have like the same style. For this model, we're using Stable Diffusion 2 and in Painting Stable Diffusion 2 because I was trying to use a more recent one, like that's higher quality, like XDXL, but that one takes too long to run on Colab, and it doesn't fit with all the other stuff in the memory of Colab. So the Stable 2 was kind of like the best, more efficient choice for now. Okay, so this takes a little bit of time. So I'm just gonna go. So you have this part here, which says create a scene from starting image. So that's where you upload this image, and then it's gonna generate a scene from here. And then this takes a little bit of time. It takes about like an hour and a half, depending on your GPU. And this one is create a scene from another room, and this is like a set of predefined um, trajectories and prompts that can generate these scenes. And then this here is kind of like how the trajectory JSON is structured, and I'll show you that in a bit. And then finally, we're gonna like visualize it, and we're gonna like see how it comes out. And this is kind of like one of those videos from the visualization. So the video moves a little bit fast, but it is because it's taking all the cameras that is seen in the generation process, and it's just gonna like record like what it's seen essentially. Like it's gonna re-render based on those cameras from the generation process. And then finally here, you can see this interactive camera plot. So these are the cameras that were seen to create the mesh. So you can kind of like see some of the uh, ways that the project or like the algorithm works, like where it places these cameras and it's going to look in these directions. It's going to project out and try to like build a mesh out of it. And then some of these, they actually have like rotations. So you can kind of like see here where like there's like okay. Wait. All right. Give me one. Just got like a weird error. Huh. Did anybody else get an error on their Colab, or was everybody same restart? Yeah. I don't know why I got that. Give me one second. Let me just double check. Okay. So one of the issues sometimes with working in Colab is that Colab gets updated. So like they'll change like the PyTorch version like every now and then, like they upgrade it. And sometimes like these dependencies they don't work on certain versions, so they kick certain errors. So that's kind of like one of the issues. There's no way to like keep the same say settings as like what should be, unless you kind of like uninstall everything from Colab and then reinstall everything, but that takes a little bit more time. So let me just double check to see. Huh, weird. Okay. Okay, interesting. All right, let me check why that is. So I ran this last night and it did work. So, when it's still in, it got disconnected and I restarted. Yeah, yeah, that's weird. Huh. Okay, let's take a 10-minute break now. I just want to double check because I literally ran this last night and it worked all the way through. Um, I'm not sure why it's given that now. Michael, can we take a 10-minute break?
Yeah.
Yeah, let's take a 10-minute break. I'm gonna check this out, see why it's doing that. Um, and then we'll come back and then rerun it again. Okay. So be back in 10 minutes. So at 34, I think it's good. Okay. Okay, so I'm back. Okay, so I figured out what was the error. But it's kind of weird. I don't know why Colab is throwing that error, but if you just hit if you just cancel when it throws you that error and don't restart, then it will run all the way through. Like it will install everything. So like this here, it should be able to run all the way through. I think there's like a conflict with some of the requirements from like another dependency and what Colab has available, that it throws this error. So it's like asking, like it's saying pretty much that these packages were imported already. So like your lib3 to reinstall the new version. So don't do this. Like when that error pops out, hit cancel, and then everything should be able to install. Um, the other thing is I updated also like the notebook. So if you wanna restart from the beginning, like kind of like go through the process of open up the notebook from GitHub, and then get the new notebook that I just uploaded with the, so it doesn't do that. You can do that or try with the one that you already have and just hit cancel and don't restart. Let me know if you guys are able to do it or like quick thumbs up if you get it going. Because it just worked for me and I used the same notebook. So at the end, you should be able to have kind of like this done, and it'll say uh, print PyTorch 3D, and it'll tell you like the version. So we're good. Okay. Okay. Let me know if you got like if anybody has it, if it worked for you. Okay, cool. All right, so it did work. So you were able to install it. So just remember, hit cancel. Don't restart. It's a weird collab error. After the Google Drive, you just clicked. So yeah, if after you click Google Drive and then sign in and connect your Google Drive, then you can go to install and hit play. And then that should take a bit of time. And if it throws you an error, like a little window pops out that you need to restart, just hit cancel. Don't restart. Okay. Okay, cool. All right, so a few people got it working. Ah, perfect. Okay, so we can keep going then, start generating some stuff. Okay, so the next part here is upload image to start. Um, so you can try this model, and I could do like so. Yeah, it takes a little bit of time to install, but it should work. Okay, awesome. Um, so this part here, we can start from like an image, um, and it's essentially all right. Let me just do it real quick to see how. So upload image to start. So once we get to this part, we can hit the play button here, and then this little text box pops out. Choose files. So go to, I guess if you have an image somewhere, I'm just trying to see if I can find one real quick. Uh, Give me one second if I find an image. Okay, I'm just gonna try this one. So like if you start with like a good like frontal image of something like, I don't know, a space, a room, architecture, whatever, um, you can just upload it. And this is gonna take a bit, it's gonna load in. Okay, so this is my image. So this is like a previously generated image. So I'm just gonna try this. This is a little bit different. So let's see what happens. And then it'll show you the image here. And then if you scroll down, generate 3D. So as default, we're gonna generate like a living room scene. So like mixed kitchen living room scene. And this is just to be able to generate like the camera positions. There's like trajectories that have been set already, preset. And here it'll tell you everything. So there's a code that's going to generate the scene. The outputs are going to be stored in your Google Drive under the text to room folder. So if I go to my Google Drive here, my drive, and then I go to, it should be under AI, and then it should be text to room DE. So that's the one, that's the GitHub file we just downloaded. And then you will see here, we don't have outputs yet on these folders because we haven't generated anything. So once you start generating, it automatically create the output folder and it'll start populating based on these things. Does the algo perform better on architectural prompts as compared to natural environment prompts? It really depends a lot on the type of like model that it's using. So like depending on the quality of the model and what it was trained on, like yes, I'm using SD2, Stable Diffusion 2.0, I think, and that one is all right. It does generate some decent things, but the prompts were engineered, or like let's say like the prompts were created so it would be like interior architectural spaces. And I'll show you how to like modify those prompts in a bit. Um, Okay, so then here, like generate outputs, we're going to generate the following outputs. So mesh files is going to be a mesh, fuse mesh folder with after generation apply. And you can kind of like read through it. The generated uh, mesh would be called this fuse final. And then like a final cleaned up mesh that applies like Poisson surface reconstruction, which is an algorithm to uh, build the mesh out from the point clouds. With depth, it's gonna be called this. These files that are like cleaned out, like the Poisson Mesh Lab, these are heavier files. So just be aware. The other ones haven't been cleaned up, and you'll see that in a bit, and I'll show you. And then you have finally like the mesh that you can bring into Blender and Unreal after that. You're also gonna get your renderings, so like the image renderings and the depth maps and the mask. And I'll show you that because we'll generate videos for that. Um, and then you get like some metadata, which is our settings, and then like some scene poses that are related to the camera locations that I showed you in the previous animation of how the algorithm is kind of placing the cameras to be able to stitch this environment together. Okay, cool. So now that we're here, so create a scene from starting image. So it says here trajectory file, and I'll show you where it is. You can actually see it says model trajectories, examples in mixed kitchen living room. So I'm gonna go there. If you go to your Google Drive here, where you have like that folder that was downloaded, the text to room D. If you go to model, so it says model here, and then you go under trajectories, and then you go to samples here. So you have this set of like room trajectories here. And these are kind of like pre-made, let's say, trajectories, right? So they kind of have the prompts with it, and then they have the camera let's say functions that's going to move the camera in some way. And then we have the baby room, which is like a smaller room, bathroom, bedroom, library, living room, farmhouse, living room, modern, mixed bedroom, bathroom, mixed kitchen, living room. So the one that I used is this one, the mixed kitchen, living room, because it does generate kind of like a wider space. Office large, office small. So I'm just gonna open one of these up. I'm gonna open up the mixed kitchen living room here. You can just double click on it, and then Colab should pop out the JSON file on this side. Uh, so you can kind of see here how it's structured, right? So you have kind of like these items within the JSON file. So each item contains like a prompt, a negative prompt, and then like the function name, which is like how the camera rotates in some way, or how does the camera move. Um, I won't go too deep into like how these functions works. They're pretty much like matrix rotations on camera matrices pretty much. But you can like modify them a bit. Like you can change the numbers, play around with it. Ideally, if you want to modify one of these JSON files, just make a copy so you keep the original one for reference. And then you can like play around and mess around with this. Um, so one of the key parts here is that it will start from this one here. So this is the initial prompt. So it says here, living room with lit furnace, couch, and cozy curtains, bright lamps that make the room look well lit. So that's like your starting prompt. And then there's also like a second prompt, which is like a kitchen with a dinner table, huge appliances like dishwasher, ovens, and countertops. No, these were pre-made from like the original code. So if you go to samples, if you go to examples here, this should be under here. So go to your Google Drive, text room the model, and then trajectories, examples, and these are all like the JSONs. And they were pre-made. So if let me just show you real quick. So text to room paper, we can go to the paper. So this is the paper from this code. And this is kind of how it works, right? So you're going to start from here. It's going to generate some camera poses, and it's going to start slowly building the scene through time. So they call it iterative generation because with time, it's going to slowly start to infill and close like kind of like those gaps in the mesh using camera poses and the in-paint thin model from Stable Diffusion. And then you can kind of like see some of the render videos from here from these meshes generated. So the living room with the lit furnace, couch, cozy curtains, brought. So this is kind of like what you would get as an output from the JSON file that we were looking at. And then this is kind of like a bathroom here. Okay, show this. And then you can kind of see more or less how it works right here, how it slowly stitches it together. So each prompt, so what's interesting about this is like that JSON file contains a prompt for like certain areas. So it's gonna like also have to set a prompt for like the ceiling, the floor, and pieces like that. So it was like all pre-made. You can modify it in the JSON file, but it is pre-made. And I think they did it because it is a little bit hard to control the camera positions. I think that's kind of like one of the issues with this paper is that the way that the cameras are generated, you have to apply some functions to be able to understand what are the missing areas in the 3D space to be able to like project or like infill in paint area. I don't know if they have a video of that part, but you can kind of see it, like it slowly starts to build it. And then there's going to be gaps, right? Because it's a depth projection of an image. So there's gaps in certain areas, and then it's going to kind of sample cameras in this space to try to find where those gaps are and slowly in-paint those missing gaps. So you can see how the ceiling is going to get in-painted there. Okay, Ali Akbar says, I got this error range error maximum scroll stack size. It might be something related to your image. Maybe your image is too big. So ideally, for this model, you want to keep images less than like 1,000 by 1,000 pixels. Okay. So let me go back to this. Okay, so then if we look at this JSON file here, makes kitchen living room. So we can change this prompt here. We can change this to whatever we want. I'm just gonna leave it as is for now, but you can like go open up the file, right? Like make a copy if you want to modify it. So I'm just gonna do it just to show, but I can't do it from here. I think you have to go into your Google Drive and make a copy. So go to your Google Drive. Where's it? Okay. Model, trajectories, samples. Okay, and here are your JSON files. So maybe you want to do mixed kitchen living room. So you can do that and then just like make a copy, right? And make, keep that as your original or something. Just gonna call it original. So we can modify the one that I have open. And then if I go back to my Colab, at least it'll save, but then we can modify this one. It'll come in a little bit. So I can take this one and I can say instead of a like maybe let's say a blue or a living room with a blue wall, uh, a orange couch. Say stone fireplace. Okay. Uh, it would take as long as like depending how if you have like an A100 GPU, like the Pro version, it should run pretty like fast. Like it should take maybe like less than an hour. But if you have the free version, it might take an hour and a half to maybe 2.5 hours. Okay, so I just changed the prompt here. I'm gonna try that and see what happens. And then what you do is like once you edit it, just Control S for like saving this JSON file here. Um, and then I'm gonna go here to this one. And yes, it is this one. So one thing that I can do is like I can go here to highlight this, go to the three dots, hit copy path, and then oops, and then just place the path there, right? And then I can hit play. So let's see now if it runs. Oh, it didn't work. Second. Okay, so I forgot about this. So one of the issues with like reading the images is like if they have spaces here, like in your image file, like the code is gonna throw you an error. So before you load an image, and I'm gonna try it again. Let's see. Just like make sure there's no spaces in like your image naming, or parentheses, like use maybe underscores or something like that. So let me just try it again. Okay, another image. So if I want to rerun this cell, just hit play again to like upload like a correctly named image. And let me just see if I can load a better one. Okay. Okay, so I changed the file name, so it's like image underscore and then number. And try to keep like the formats like this, so there's no errors in this thing. All right, let's see if the loads. Okay, so it loaded another image. Okay, cool. So now let me try this again. I'm gonna hit play. See if it loads. Okay, so it seems like it's loading. Trajectories length is downloading the JSON with the model files. So this is downloading like your stable diffusion in painted models. This should take a bit, but you should be able to get this. I just want to see if it throws an error, but it should be starting to generate images pretty soon. This takes a little bit of time to download because it's downloading like some model weights for stable diffusion. Okay, so it seems, and then it downloaded the weights for stable diffusion, and then the other thing it's gonna do is gonna check if we have like the depth prediction weights and the normal estimation weights. Let's see if it goes. Okay, so it's downloading some more stuff. Okay, so it's downloading the depth prediction model. What do you mean when you say a camera movement function? Okay, so you see, like, you should get this, right? Like now it's running. Now it's starting to generate based on this prompt here that I edited. It's gonna start generating images. So it's gonna generate like 9 images, and then it's gonna choose the best image to be able to stitch together like a set of images. And the way that it's selecting this kind of like the best images out of this 9 images is that it's gonna check the mask of the images, which one has like the most space to fill the gap. So initially, obviously, there's a lot of space, but later on, it'll narrow down to like better images. And I can show you that. I don't know if it's gonna show it here yet. Let's see. Second. So like now, if you go to like that folder again, and then you go to output, you see like it created the output folder, and then it created this other folder, which is like the mixed kitchen living room folder for this JSON file. And then it's gonna create a full trajectory folder, and then the prompt folder. And then this is like starting from like the image name, right? And then here's like the date and the time. And then if you keep going, finally you get to the outputs. So you have your depth map here, right? And if I take a look at it, let's see if I open it. So this is the depth map projection from like the initial image. And then if I go to, let me see the, it's RGB. So this is the initial image that I started, that I fed into the model. And let's see how the depth does it. So the depth, this is how the depth projects it. So like a lot of the issues is like we're using like a pre-trained depth projection map. So some of the things are gonna look all right, and they're not gonna read it if it's like an AI generated image sometimes. But it does its best. And then if I go to the mask for that, you can see this mask here already rotated, or like the camera rotated around the image. So the black part is the projected image of the original image. And then what it's seeing is this white space that it has to like inpaint, right? So it's trying to figure out, okay, how much in space, how much white space or empty space do I need to inpaint? And then it's gonna start filling that up. And then if I go to the next depth map, you can see how it like rotate the camera, and then you see the white outlines is like those missing gaps that it's gonna try to inpaint, and it's gonna try to complete the image. All right, okay, and then under RGBD, this is like both the depth map and the original image, so you can see that. Let's go one to further down. So you can see it here. So you can see now like it didn't match like the original image because like it's not able to like read the style. You kind of have to figure out how to prompt it. So for this model, I like using better just like create a scene from scratch instead of from like a starting image. But this is just so you guys can like test it out. And then you can see like the depth map projection and like the stitch. This is how you call it. This is like a render view of like the mesh in 3D world, essentially. And then, oops. Okay, so it's gonna keep going doing that. And then if you go to if you go to fuse mesh, I don't know. Okay, so this is like your first mesh. Let's save as a fly file. So this is your starter mesh. It should take a while. Like I'm only gonna let it run to like the first 100 iterations, but this should be able to run to like 250 iterations. And then it'll do like a Poisson mesh cleanup. And let me see. Let me just go here. Okay, so you have your folder here in your Google Drive, trajectory. Okay. Right, and then you have the mask. Okay, and this is like all your masks. So like if you open this, like you can see how it kind of like the cameras are moving and which images it is selecting to like in paint, and how the process essentially works. So it's pretty cool. Okay. So Jax said, what do you mean when you say camera movement function? How are they defined in the JSON? Is it possible to edit those too? For example, if I don't want to navigate in a room, but rather navigate on an object. So the camera functions are right here in the JSON. So they're called like FN and then name, so function name. And it says forward. And this is defined by code. It's kind of like hard coded. I don't want to get too much into it. You could modify this, but it's pretty like straightforward. Did you get an error? All right, let me, oops. Well, let me starting to lag. So like, let me just, yeah, I'll answer this question real quick and then I'll check that error. So function name forward, that means like camera moves forward, and then here's the height is a 0, 0, and there's no rotation, right? So these are your arguments to this function. This one has rotation left, up, down, right? So it's gonna rotate the camera, and then 0, 0. And then these ones, sphere rotation. So this is the one where the cameras kind of like rotate around from a point, and then it has like a height and then a radius and a phi, which is kind of like how often it moves, or how often, what is the angle of rotation essentially. And then adapted is the radius, so like how far off from the point it can move. So there's some noise, let's say, in the way the camera moves. And this one here, rotate up, left, down, so same thing. So these numbers here, Jack, if you can modify these numbers. I just gave them preset because like to be able to like dig in and like go through how to like modify these functions, that would take a little bit more time, and it also requires some math. And, like you would need to know how to like, how to multiply matrices and stuff like that with cameras. And I can show you where it lives in the code if you want to take a look closer. So if you go to the text room to room DE and you go to, should be under utils, second, model def alignment. Distribution. Let me see if it's under utils. This one. Okay, yeah, here. So if you go under trajectories, and then there's a trajectory util, right? You open that up, and here is like the list of functions, right? And you scroll down. So these are kind of like presets. So this kind of tells you like what to do, like what it's doing, right? Translation, rotation, tilt left, negative tilt right, right? So they already have preset this. So it's like easier to use with the code. And then further down, see, further down, these are the ones that are using the JSON file. So this is the one that I was showing you, like forward, right? And it says like how much, right? TX max is like how much should it move forward, essentially. Um, and then backward, right? Backward three small. So you can go through this and like see and it's all in this file, so you can like test it out individually. But I wasn't gonna go through this because this is like a lot of math stuff. Okay. So val yang, I got a runtime error the size of tensor. Val, where did you get that error? Because it's created. Oh, is your image like an RGB image? Like is it like a regular RGB image, or does it have like another channel? Because that might be the case. Uh, try with like another image to see if you still get the code, but it shouldn't have an issue. It's usually like that error is related to like the channel size, which means like RGB, plus something else, alpha or whatever. But it should be like just three channels. Okay. Um, sure. So this is still running. Let me see if we got more meshes out. Let's go to fuse mesh. Okay, so we have another mesh out, which is like frame 50 or like 50 iterations. Um, okay, so you can keep it running. It's gonna go to around 250. And then that'll take like a little bit of time. I'm just gonna stop. Good news when it crashes and you reopen. Yeah, that's like you mean like it just freezes the Colab notebook? That's like an issue with Colab. Like if it prints out too many things here, it'll crash. Like it'll crash the UI. So like sometimes what I do is like I just hit the like if you scroll here, I just hit the X and like reset it. So it doesn't like build up like this kind of long list of text. Okay, so I'm gonna stop. You guys can leave it running on your end. I'm gonna go to the other part. I'm gonna stop this part. Um, and you can like open up the mesh. Like for example, yeah, let me just show you guys that real quick. So if you go, I'm gonna open up Blender. And we're gonna open up like the generator mesh, what it looks like. So let me go. So when you open up Blender, you can go to import, and I'm using Blender 4. Import Stanford Ply, and then I'm just gonna go to my Google Drive, AI, output, trajectory, and then I'm gonna go to Fuse Mesh, and then I'm gonna open up this one. which is like the 50 iteration one. Up axis is Y because it's using like a different coordinate system in PyTorch 3D. So if I hit it, see what it brings in. Okay, so that's the mesh that we got so far in that iteration. So this is like, I guess like 50 iteration, right? So you can see like it did stitch some things together, like it did kind of go around, right? And then it's slowly kind of making its way around it, and it's gonna start filling in those those gaps here. And then I guess I can show this now, but to be able to see the shade, so like right now it's just a white object. It has no material. You can go to shading here on Blender tab, and then hit new, right? And then it creates this principal BSDF, like this fuse material. And then what you're gonna do is you can hit Shift A, which pops up this search bar, and you can hit and go ahead and type attribute, right? And this is going to give you this attribute. And under here, where it says name, you're going to type in capital COL, and it stands for color, and then you can plug this in. So now you get like a texture 3D mesh. And I'll show you what this attribute means. If you go to geometry nodes here, let me look at this. Okay. Right, this is your mesh. So let's see where the initial, so you see where the initial image is? This one here. So it kind of turned it into a pool or some sort. And it projected it out, but it does, like everything around it doesn't match up. It kind of just went around it, tried to build something out of it. But yeah, it's kind of interesting. So if you select the mesh, and over here on the left side, it says position and then call, right? So position is like your vertices of the mesh, and then it also has the edges, and then it also has the faces, right? But if you go to vertex here, these are all your vertices of the mesh, and they have that location, and then they have like the color for that vertex. So like this is your color here representation. One is the alpha, so one is it's obviously opaque. And then each vertex has its own color. So what we're doing is like getting this attribute from the original ply file and then applying it to the shading of each vertex for this mesh. And that's what we were doing here with the attribute. Okay, so that's how you'll be able to visualize this, and then I'll show you how to get the UV texture so you can bring it into Unreal. Okay, let me go back to the Colab, see how it's doing. Okay, so it's still running. I'm gonna stop it for now. Okay, you guys can let it let it run. I'm just gonna stop it, so I'll show you how to do the other part. The other part is pretty straightforward, but it's just to create a scene from any room type, and it doesn't use like a starting image. So what I can do now is, for example, I can either, okay, give me 1 second, I key over trajectories and creating a scene. Yeah. So, okay, I just went over that, but I can go over it real quick. So in this part, create a scene from a starting image. You have a trajectory file. The trajectory file lives under model, trajectories, and examples, right? So you have these JSON files that pack all the information for the camera functions and the prompt, right? And this is what the model is going to use to generate cameras and generate the prompts to essentially generate like an image and then paint it. And you're just gonna select one of these. These are all pre-made, so it's like easier to use. But you can select one of these or make a copy And then you can open it up, for example, by double clicking, and then it should pop out here on the right side. And it's mixed kitchen living room JSON, and it says prompt, so you can like go and edit this prompt and modify it. You can keep the functions. These are the camera functions. Is this an example folder I can see? No, it's under your Colab. So like if you go, when you install the Colab, or like when you install like all these like this let's say GitHub project, you should have like a AI, like if you go to your drive, go to AI, and then you should have a folder called text to room DE. And then you can go down to trajectories, examples, and then you should have like these JSON files with the trajectories. And if you open one up, this is kind of what it looks like here on the right side. So you have prompt, living room, so on and so forth. And then FN name means function name. So this is like the function that the camera would do. And this is kind of all preset. I'm not going how to make these or how to do this because this requires a lot of math. It kind of all been preset, but you can like mess around with like the numbers or the prompts and then see how you can modify it. Okay. I hope that answers your question, but it should be in there if you stole everything. Okay, so I'm gonna keep going because time is running. So okay, so you can do that, and then you can, if you want to do it from an image, then just hit this button here, and it's gonna say choose file. So choose your image. Make sure that the image doesn't have any spacing or parentheses, like that the file format looks clean. So image underscore whatever. And then it's going to upload it, and then also make sure that it's less than 1,000 pixels wide. It should resize it automatically to 512 by 512, but it's better to have it like smaller size. No, the image is just a starting point. Like it really won't affect that. That's why I just wanted to show it, like to see how, like to show you guys how it works. I don't really use it because it doesn't match the style of like the preceding generation. Um, so it was just to show you how it works, and like you can kind of like see it here, like how it actually looks once it like finally comes out, or like once it starts generating. Like here's the original image, so it just kind of like stitches it. It projects it out of it, like it doesn't do much, uh, which is kind of like the weird thing about these models, that we're relying on pre-trained models, but then it just stitches everything else. So here's my prompt, like a blue wall in the living room. So that did work. And then there's the orange couch. So it works a little bit better if you don't kind of like do the initial image, because then you have to like try to figure out how to match the style. Okay, so that's kind of like the image part. So I just wanted to show like it is possible, like you can start from this, maybe eventually like in a few years or something like that. We don't like it'll automatically get the style, and then it'll be able to generate the space with that style. Um, and then the next part is like create a scene from another room type. So this is like using one of these, so I can use either the same JSON file. So I'm gonna try that one. So a living room with a blue wall, right? Living room with a blue wall, big orange couch, stone fireplace, and a big. I'm just gonna put like round windows to see if it generates round windows. Okay. And then you can save that by hitting Control S. Um, and then I can just hit play here because this matches my JSON, right? This one here. If you want to use another one, you can get these three little dots, hit it, and then copy path, and then put the path here. So I'm just gonna hit play on this one and see what it does. And it should automatically start generating. It'll take a bit, and it'll start loading everything. Okay. Okay, so there it goes. It's gonna fetch the models, stable diffusion models, and the prediction models. Was anybody able to get like a mesh kind of like what I have here, like for those initial iterations? Okay, cool. Yeah, as long as you're able to get like, one of these meshes, you should be all right. And then we can use it later on in Unreal. Yeah, okay. So I'll show yeah, let me I can show like the import to Blender real quick again. Um so I'm just gonna delete this and I'll do it again. So if you open up Blender, you go to File, and then you can go to Import, stamp for apply, because it's apply file, apply mesh file. Um, and then find your mesh. So wherever folder you saved it, this one here. My up axis is Y. I have to change it to Y because the PyTorch 3D has a flipped axis, like the axes are facing the other direction. And then I can go to import apply, and then it should take a bit, and then here it is, right? So that's your base mesh, and then you can take that mesh, and then if you hit on it and you go to geometry nodes, you can see the properties of this mesh. So like for each vertex, it has a position, and then it has a color, right? And what we want to do is like map the color per vertices to this mesh, and then you can do that by going to shading, and then you go to new, and then you can do, it'll automatically generate this, and then you can hit Shift A, and then this little text box pops out. You can go to search, and then just type in attribute. So I already have it here. And then we can go here to name, and we're gonna copy the attribute name. So the attribute name, if you go here, it says COL for color. So capital COL, and this is your color. And then just copy it here, write it here, and then connect that to your base color, and then you have the color texture mesh. Okay. Does anybody else have any questions? I'm just waiting for this to run a bit. Okay, so my other generation is running at the moment. So you can see it going. I'm just gonna check on it, see how it comes out. Okay. So I go to mixed kitchen living room, full trajectory. Uh, this one, no input image file. This one here. And then let's see how the RGBD is looking. Okay, so this one is just generating like a regular living room. And then you can kind of see the fireplace and the blue wall. And I guess that's the orange couch right there. Let's see. Yeah, that's the orange couch. So there's the blue wall, and then the fireplace, and then the stone, I guess it's made it around it, so it didn't put the fireplace in the stone wall. Um, but it's cool. I don't see any circular windows here. Okay. Oh, actually, there is one. There's a circle, kind of like a circle window there. All right, so it's like starting to build it out. Cool. All right, so I'm gonna let that one run a bit. Can a prompt be, for instance, in the style of Renzo Piano? Yeah, you can try that. I I haven't explored that deeply with those prompts, type of prompt, but if you go to like the JSON file and you can like add it here, right? Where it says prompt, just like add in the style of so on and so forth. That would largely depend though on the stable diffusion model that it's using. So like I don't know if SD2 understands all that, but if it's scraped the whole internet and it's trained on data from the internet, then it should be able to capture something like that. So you can like try, you can just add it to the prompts. Okay. Okay, and if you scroll down in the Colab notebook, there's this piece here which says modifying creating trajectories. And this kind of shows you the structure of the trajectory, which it kind of like went over a little bit. This one gives it a little bit more general, so like what each of these things do, um, with an explanation. So you can like kind of go through this and then see how you can modify the trajectories. It's a little bit complicated in a sense, like you have to know more or less what the function is doing. Um, but you can mess around and then test it out and experiment with it. Okay, so after that, we can go and do the renderings. So I'll show that in a bit. And then after that, we can do Blender UV texture, and then we'll go into Unreal. Um, so I'm just gonna let this run a bit. Let's take like a 12-minute break, and then we'll come back and we'll do Blender and then how to import it into Unreal. Michael, is that cool?
Yeah,
Um,
just take whatever break whenever you want to take a break. Just take it. Yeah, it's fine.
okay, cool. James, the shortcut for the search the attribute. So if you go to shading and then you just hit Shift A, like Shift, like you have to be inside of this box, and then you hit Shift and then the letter A, and then it should give you this little text box. And then you can hit search and then just type in attribute. So Shift A. Or you can also go here at the top, right? It says like add. And then it should be under where's input. Yeah, it should be under add input and then attribute. Yeah. So you can find it there, add input and then attribute. Yeah. Okay, cool. Yeah, so let's come back in about 10 minutes and then we'll go over Blender UV texture and then how to import into Unreal. Okay. See you in 10, guys. Hey guys. How's everybody doing? Does everybody have like a mesh file running still? Okay, cool. All right, this one, yeah, it'll take, I think it'll take a little bit of time. It'll take close to 2 hours, depending on your GPU. Um, but we can keep going. Yeah, yeah. So if you, depending, I don't know what kind of GPU you guys are using. Like if you're using the free version uh or like a pro version, but yeah, it'll take about 2 hours. It goes up to 250 iterations. Um, Here, let me show you. I think I sent in that sample folder. Sorry. Let me show you from the previous one. Okay. Outputs. It was this one. Yeah, it goes up to like 250, and then from there it like does like several iterations to clean up the mesh. Um, and that should take a little bit of time for cleaning up. But then you'll get like this kind of nice clean mesh after. So this is from previous one that I ran. And this should be in like your sample folders. Um, and then it goes here after. So it should be 200, right? And then from 200, it goes to this after generation ply, and then it'll do a, a generation Poisson mesh reconstruction. Um, and this part takes a little bit of time because it's gonna like clean up the mesh a lot. And it'll fill some gaps and clean up like weird um, vertices or faces that don't line up or that are kind of like floating in the air. So yeah, this will take a bit of time. Uh, so yeah, 200. If you're at 150, then you're close. Like 200, you probably have like another 30 something minutes, 30, 40 minutes. Okay. All right. So, all right. Yeah, Colab crash. Yeah, that happens sometimes with Colab. Um, okay. Yeah, Shift A. Okay, cool. If nobody has any questions, I'm gonna move on to the Blender UV texture map. So I can show that, and then we'll go into Unreal. Okay. Um, Meanwhile, this one runs. Okay. So back to Blender. Um, all right. I'm gonna grab like one of the, maybe I can do this one. But this one is not gonna look as cool in Unreal, but we can try it. But yeah, I'm gonna grab like a clean finished mesh, and then I'll show you what's the difference and how it comes out. Okay, so I'm gonna use this one, which I ran yesterday and last night. I haven't seen what was the final output yet, so I'm kind of curious to see what comes out. And this was using another type of trajectory. So I'm gonna go. So what I'm gonna do is select this one. So you can see like the file sizes here for the split files. So they gotta increase in size as it gets to the final one. And then the final one, which is like this reconstructed, clean, smooth mesh, 443. So it's decently heavy. Um, so I'm gonna open that. Okay. Yes. And then let's see what happens. All right, so it's gonna take a little bit to load because it is a heavy mesh. Okay, so you can kind of see it there. Let me just take this off. Okay, so this is like a final constructed and like cleaned up mesh. Um, so you can kind of see that it is an enclosed space, right? Like it is, this might be even 3D printable, I think. Um, but it is an enclosed mesh. And then you can kind of see the interior here. Right. So there's like some weird artifacts, obviously, that comes with this generation, like this kind of things on the ceiling, um, and things of that nature. Some weird patches. The furniture is there, but it's like blended into the wall, because it has to be like a fused, like joint mesh. All right. So I'm gonna redo the texture again. So if I go click on this mesh, I go to new, then I go to attribute, right? Shift A, attribute, color, and then you see it's like black because we didn't add the property. So I'm gonna add the property of the color, and then here it is, right? So this is your render mesh. Okay. So you see like the couches there? So it's like it's kind of funny because they're not semantically or strategically placed. It's kind of just based on the image. And this is why I was saying like it is important. That other method that I showed, which is condition on layouts, that might be more useful for architecture of these types of methods if you can combine them, because then you can actually place the couches and things like that in a way that makes like sense. Okay, cool. So now that we have this mesh, we can't really use this in Unreal. We have to like export it as an FBX. So and the way to do that is that we have to generate like a UV texture, a UV map texture for this mesh. And that way, when you export it as an FBX file, you can embed the texture within the FBX file. And then that can get exported into Unreal, and Unreal likes those types of files because then it'll create like the material with the mesh. So it'll have like the textures and the material all set up. Okay, so like to go about that, what we're gonna do is gonna change. So if you go here uh to this upper left corner, you can like change this window. So I'm gonna do that. So we can go to the UV texture properties. So if I click this here and then I go to UV editor, it's gonna open this up, right? What we have to do in order to bake the mesh. Okay, so we have to create, if you go to Shift A here, search, and then we're gonna use image texture that we're gonna bake. Okay. So this is a brand new image texture. And what we're gonna do is go to new, and then we're gonna give it a name. So I'm gonna call it know what this is. Okay, I'm just gonna call it so I can remember. And then you can change the width and the height. So like this is like, you know, what 1K size texture. You can change it to 4K. That's up to you, but I'm just gonna keep it like this for now. It works decently fine for Unreal. And then I'm gonna hit OK. Okay. So that should have created a UV texture. And then if I go here, you should see like it's already there. Like it created this kind of texture. And we're gonna use this to unwrap the texture from here onto this, and then we're gonna bake it, and then that would give us a new texture embedded with the mesh. So one thing to do before that, okay, so just make sure that this is correct. So this should be color space sRGB, so that's fine because we're gonna just use like a diffuse material. And then what we got to do is go here on the right side to render, and then go where it says EV, change it to cycles. So these are the types of rendering engines from Blender, but the baking only works within cycles. And then change it to GPU compute. Okay. And then if I go here, scroll down, there's a section that says baked. And we're gonna go here where it says bake type to diffuse, right? And then we don't want indirect or direct light on it. We want like a clean mesh, just the color. Okay. And then this is fine. So your image texture is fine. Okay, JSON face is fine. So all this, these are just like the settings. So this should be good. And once you have that, then you can go back up here to render. And then you can change this to 10. I think it should be enough. You can keep the noise on. And that should be fine for this part. So once you have that, then what we're gonna do is we're gonna select this mesh, and this is gonna be like a computationally expensive part because this mesh is so heavy. But if you click on the mesh and then just hit tab, it should go into edit mode. So it's gonna pop out all the vertices, and because we're gonna use that to project the texture. So it's gonna take a little bit of time to do that. Okay, so like now we have it. So we have all the textures here. Okay. So you can kind of see all the vertices. So now what you're gonna do is you're gonna hit A to select all the vertices, right? So it selects all the vertices. And then if you hit U, like the letter U, you're gonna get these UV mapping options. And what you're gonna do is go to Smart UV Project. Okay. And then from there, you can just hit OK. And this is gonna take a bit of time, but it's gonna unwrap like all the UVs of the mesh. And it's gonna show it here on the left side. So that's gonna take a little bit of time. Okay, so it's done. So now if I zoom in, oops, just and now I can exit the edit mode on this by hitting tab again. and it'll go back to object mode, right? Okay, so now if I don't know if you can see it here, but it should have like all the vertices mapped up. It's just there's a lot, so you won't be able. Let me see if I can see it again. A depth as yeah, you can use different ones. Um, you can use different depth models. I didn't do it for this part. Like I didn't switch them out. Like you can use like ZoDepth or Midas or whatever is kind of like common. Um, with like Comfy UI or things like that. You can switch it out. The one that is used for this is like very specific. It's called Iron Depth. And it has like a component that also estimates like normals. So it estimates the depth and the normals, and then it like uses that to create like a better representation of a mesh. What was the step after U for UV? If you hit U and then you go to UV Smart Project, you can also go here on the tab above, but you have to select all the vertices. So press A when you have it in edit mode. So here's edit mode, right? It says edit mode. And then you press A, and then it should select all the vertices. And then go to UV and then do Smart UV Project. And that'll wraps it onto here. And then you can see here, this is like the mesh, I guess like projected onto this plane. And then you'll see like it's a lot of little like triangles. But what it's gonna do is gonna take the color and then project it onto this. Okay, so now that we have that, I'm gonna exit out of this. Okay, and then I can select the mesh. Okay. Okay, and then sorry. Okay, so they're located in the Colab. I cannot follow. Do you mean for like the depth models or which are you talking about? And yes, Ali, you can adjust it in ZBrush as long as you're able to export it as like a FBX model with an embedded texture. I don't know ZBrush, so I'm not sure. But if you know how to do that, yeah. Yeah, the depth model is embedded within like the GitHub file that you downloaded. But I didn't change like so I didn't add like ZoDepth or like Midas. So like you can do that if you know how to code and like attach it to it. But yeah, what is the bake options we choose? The bake options. Oh, okay, okay. All right, so I'll show that right now. So once you do the UV unwrap, and then if you go to like your render here, if you go to render here, just change it to 10, max samples to 10, and then you can keep the noise on. And if you scroll down to bake, you can just go here to bake type and then click diffuse, because we only want to do like the diffuse. We don't care about any other like texture types. And then just leave color on. So on click direct and indirect, just leave color, and then everything else should be good. And then what you do is just select the mesh and select the texture here. And then you can hit bake. Yeah, select this here, and then the mesh, and then hit bake. And then at the bottom it says texture bake, so it goes, and it should be done. And then here it is. So now it baked the texture. So now we have this texture as like a texture image. What you can do now is like you can essentially go here. Oh wait, not there. Save it. You can save this, somewhere. Don't know where to save it now, but no active UV layer. I'm sorry, which part are you on? Or Sada, can you tell which part you're on? I click bake. Did you have these options here, like so? And then you have to click, you have to select the mesh object, and then have this image texture here selected as well. And then hit bake, and it should go. Okay, yeah, if you have it selected, so it should be under object mode, yeah. Edit, when you go to edit mode, that's only when you want to get all the vertices and project them onto this texture. But when you want to bake it, you got to go to object mode and select the object and select the texture here. And then it should bake. And just make sure that you have the diffuse and all these settings correct. And then I just save this texture to like the file folder, just so I have it for reference. And you still didn't bake it? Like it didn't pop out like this? Were you able to unwrap the mesh correctly? Like were you able to get the triangles protected here? Can you please? Yeah, sure. Um, okay, so if you go here, like when you have the object here, you want to just go, like you can do it in two ways. You can either hit tab or you can go to here to object mode and just go to edit mode, right? It'll take a bit because it's quite a lot of vertices. Um, so I'm just gonna wait a bit till it loads. Okay, so here, and then I have, right, it has all the vertices selected. To select all the vertices, you just hit A, and then it should select them automatically. And then what you can do is like you can either go here to UV and just do a smart UV project, but where you have this image here, um, this image texture should be the one that we created here, right? The fuse mesh texture. And you just have to load it here, right? It should be, if you click here, it should be this one, but blank before you project it. And then once you do that, you load this here, then you can hit UV here with all the vertices selected, and then do smart UV project, and then it should map the vertices to here. Let me know if that works. And And once you have that, then you can bake it essentially. Like that's all the process that you have to do. Sada, you're good? Okay, cool. Yeah, and then once you have that, then you can go back to object mode. Um, and it takes a bit because it's like heavy mesh, but and then you go back to object mode, you set up all the bake settings, right? Make sure you're on cycles. You can set the render max samples to 10, and then select your object and select your texture here, and then you can just hit bake, and then you should get this. Okay, cool. So it works. All right, awesome. Um, okay, so next part. Okay, cool. So now that you have that, now you have like a fake texture. What we can do, which is interesting, is that now we can test it. So let me unplug this here. I'm gonna plug the attribute node, right? So it is blank, and then I'm gonna use that bake texture to see if it works. Um, and what I'm gonna do is if I plug this in here directly, it's there, right? But there's some weird things. You can also do it where like you can add the texture coordinate. Second. Right? So you can do it like this way and then just plug the UV to here. And then that should be the mesh. This is to make sure that like it matches like the UV. Um, and then there it is. So the texture baking worked. So now what we're gonna do is export it as an FBX. Okay. So what you're gonna do is take this mesh, go to File, uh, Export, and then you're gonna go here to FBX. And then save it somewhere. Let me see where I can save it. Okay, I'm just like saving it right now. You guys can save it wherever you want. Um, just gonna save it here somewhere. Okay, cool. So once you have that, there's like a few options that you got to keep in mind when exporting as FBX. So find where you want to save it, and then you're gonna go here. Um, give it a name. Like, what's your mesh name? I'm just gonna call it Fuse Mesh. So, um, okay, and then you're gonna go to selected objects here. So like limit to selected objects. You can click just the mesh, right? And then let me see if there's anything else. Okay, I think yeah, that's it. And then path mode, and then you're gonna go to copy, and then you're gonna go to this one here where it says embed textures, and you're gonna click it, and then it should turn blue and pop up this thing. Okay, and once you have that, you can just export it. And it should take a bit of time to export, depending on the mesh size. All right, so it's still loading. Yeah, it's gonna take a bit of time. My Colab's still running. All right, cool. Okay, so it should be exported now. Um, so if I go to wherever I saved it, it's gonna find where I saved it. So you can go wherever you saved it, and just make sure that it's saved. So you should have something like this where it says like views, mesh, Poisson, FBX, right? And it's pretty decent size file, 600. Yeah. So I didn't do any like post like mesh processing in Blender to like clean it up like or reduce the mesh count. So it is rather heavy. There's probably like a post-processing method. I'm not gonna go over that right now, but you could probably clean it up and reduce the number of what's it called, triangles, or like smooth it out a bit more so it's not so heavy. Okay, so once you have that, then now we can bring that into Unreal. So we'll go into Unreal. Does anybody have any questions on the Blender part, or we can move on? Okay. Are too close to Blender to save RAM at this point? What do you mean? Are we no, that should be, yeah. I mean, that should be it for now. Like we can, I was gonna show geometry nodes, but I think it would be too much plus the Unreal. Like, cause you can do like some, like geometry nodes in here. Um, but it'll be, yeah, like we'll do the particle animation in Unreal. That should take a little bit of time. So just for like time wise. But that should be it for Blender. That should give you kind of like what we need, like the FBX with the embedded texture. All right, cool. So I'm gonna close Blender out. Let's see. I'm just gonna save my Blender file. Okay, so now we're gonna go to Unreal. So I send you guys the Unreal zip file. It's pretty big. It's like 1 point something gigs. The original file. I would recommend if you guys just want to follow that one, so you guys have everything. It's probably easier than to like kind of go, step by step. At least you have like kind of like a reference to guide. Um, and so I would recommend like for you to download like that Unreal file, the zip file, and then unzip it, and then open it in your Unreal. And I'm gonna like open that file now. Right, so I'm gonna go to Unreal. I have 5.3, launch. Gonna take a little bit of time. Okay, so the name of the file is nh workshop sample. I'm gonna open that one. So I'll wait for you guys to download it. Just let me know, like, if you guys are able to download it from the sample files. I think, yeah, if you go here to workshop and then Unreal files, this is the Unreal project file. You give me a thumbs up, or just if you're downloading it, or if you're able to open it, let me know. Okay, cool. Download and zip. Yeah, it's gonna take a little bit. It's massive. Like the Unreal project files are massive. Okay. So I'm just gonna like start. So like you should get this. Like this is kind of like your starting point. So we started like when you like open Unreal, like I started this from a third person template, which is kind of like so you're able to get the little avatar player. Um, and then what I ended up doing is like I created like these folders. So if I go to content, I have a blueprint folder. I have a levels folder, materials, and then like the mesh, and then a Niagara folder. And these are the folders that I created to separate some of these things. And if you go to levels, you can go to neural level, and that's the level that we're using. And you can do this kind of like on your own too, where you can, like, if you start from scratch, you can just go to right click and then just go to create like level, right? So you can call it, I don't know, whatever. Like new neural level, let's say, and then it's gonna create a new level. And then if you click on it, yes, so you selected, it pops up an empty level with nothing in it. Okay. And then what I do for that level is I did two things. So I wanted to set up light and like a plane where like the character can walk on and then place the character, right? So if you go here to the actors, you can do shapes. And then you can do a plane, I guess. Yeah, a plane would be fine. It places a plane on here. And then if you hit F, it should zoom into that plane, but that plane is like really small. So I'm gonna like scale it up a bit. So if you click the plane and then you go down to transforms, there's a scale here. And you can do, I don't know, let's say 100 by 100. So you won't fall off with the character. Okay. So you can't see it because there's no light. So I gotta add some light to this. Same thing, you can go here and then you can go to lights. And I'm gonna use just directional light. Place it higher up, right? Okay. Directional light just to give us some light. And then when you click on it, if you go to the properties here below, we have light intensity. So you can change this. I mean, it's at 10. I think it should be fine for now, but you can make it brighter. You can dim it down, let's say. Let's see at 5. Okay, cool. And then once you have that, you can also change some properties about this plane. But first we need a character or an avatar to test it out later. So let me go here. And then I'm gonna drop player. Okay, player start. So I'm gonna hit that one, and that's gonna drop the character down. You can also change like the height of this plane. You can also go here where it says perspective and just like go to like a left view, and you can see where the plane is. You can see where the player is, right? So I'm just gonna move this to 0, 0. So everything's like center. So under location, I just moved it to 0, 0. And it's scaled by 100 by 100. So you can see the plane here. And then my character is way up here. We should be fine. He's just going to drop. And then this should have, we can check if it has collision, but it should automatically have it. Okay, relevant. Okay, so it doesn't have collision presets. Okay, so now what we can do is like test to see if the character stays on the plane, and there it is. So here is the character. Okay, and we can move around with like WASD and then rotate the camera with your mouse. Okay. Cool. And then we can go back here and just go back to perspective. Okay. So, okay, what are we gonna do now? So we're gonna like import the mesh, the FBX file that we just created from Blender. And we're gonna do some Niagara particle animation on it. So if I go to, well, I already have it here. So this is the one that I had from from like the work samples. But if I go to, let's say if I drop the new one that I just created. Okay. So I'm gonna drop this new one that I just created from Blender. I'm gonna drop it here into the mesh folder. It's gonna take a bit. This is like really heavy. So depending on your computer, like you might need to like set the number of particles later on to a lower rate. Okay, so like these are options from the FBX file. So if we look at it, okay, generate missing collision. We can take that off. We don't really need that because we're gonna be walking through it. Combine meshes is fine. Everything else should be fine. Yes, yes, yes. Okay, and then it's gonna import the textures and the materials. Okay, so everything should be good. So now if I hit import, it's gonna start importing the FBX mesh. Give me 1 second. I'll be right back. Okay, so this should take a little bit of time until it imports. So you can do two things, either import like the one that you created, or you can use the one that I already imported in the sample file, just to keep things easier, and then you can go back to it. All right, so 80%. So those hairy meshes, they were like based on the, so I'm not teaching the hairy meshes part. That was done in Blender, but I'm gonna show you how to like instantiate like particles, similar to the other ones, that I showed kind of like earlier, uh, with Niagara in Unreal. So they're mostly like instantiated, like kind of like cubes or like particles, that I've been using. And then you just like animate them so they have this kind of like effect. I can do it once, but I have to come back and clear. I mean, you have like two options. You can like let it run until it finishes. What ends up happening is like it prints out so many things. Like you would have to like go back to the original code and like delete all those print statements. Because the original code wasn't meant to be run on Colab, it was meant to be run kind of like a strong Linux computer, and it doesn't have those issues. But you can like let it run, and then once it's done, you'll see like it'll finish, and it'll like Colab will go back to normal. Okay, still important. All right. All right. I hope this mesh wasn't too big because it's still important. Oh, okay. Finally. Okay. All right. So now we got it in. Okay. So when I let it run with that clearing, no, yeah, the Colab will crash because it's trying to like it's running and then it's like processing like all this thing on the web. So like the JavaScript like can't handle it sometimes. Um, but it'll be fine. Like it's still running. You can check like your Google Drive and check like the folders where like all these images are being saved, and you'll see like it still like populates them. It's just like Colab issues. So. Okay, so then I get this window here. After it imports, yeah, it has some here tangents. This is like it is a generated mesh, so it's not as clean and as a mesh as like one that you would probably model directly. So there's like a tolerance to like certain things, so you don't have to worry about these errors. Um, I added the player. Yeah, sure. So if you go here. To this one, uh, I guess cube with the plus sign, and you can go to basic, and then you just go to player start, and then it should automatically like create like the player. Okay. Okay, so we got the mesh here now. So fuse mesh, it has over 44 million vertices, 14 million over 14 million triangles. So it's pretty big. Let's see. Let's see what happens. Okay, cool. So it opens up. I might not be able to work with this while streaming. Okay, so one thing that you want to do, like when you open it, it's really laggy on my part, so I might have to use the other mesh because it was a little bit smaller. Um, but you can go here to collision and then just go to, okay, so collision's already removed because when we instantiate it for the particles, we don't want to like bump into the mesh. We just kind of want to go through it. So if the collision was activated, then you would go remove collision. Okay, so that should be good. And the materials there. Okay. All right, I might not be able to use this mesh while streaming. I think it's too big. My computer's starting to lag a bit. So I'm gonna use the one from the sample file, which is a little bit smaller. And we're gonna work with that one. So what I can do is like I can like drop this one here, right? Let's see. In Unreal, gonna place it there. And there it is, right? So that's our texture mesh in Unreal. Okay. And then if I hit play, there's our object, right? Right? So if I jump through it, like you see that it's not colliding, so it goes through, so that's good. Okay. Uh, so that's working. Just lower it a bit. I'm just gonna lower it so we can go inside of it. Right? So we're now like inside of the mesh. And here's the kitchen. Okay, cool. So now we're gonna do some animation to this mesh. So we can delete it from here because we're gonna instantiate it in a different way. What we're gonna do is we're gonna go to Niagara, and we're gonna do let me see. Yeah, we're gonna do this. So this is like a very simple particle animation, and I'll show you how to like add forces and things like that, and how to instantiate like the mesh and the texture. Um, so let me see if I can do it from scratch real quick. Okay. So in your folder Niagara, you can just click here, right click, and then go to Niagara system. So it's taking a bit to load. All right. Okay, give me 1 second. I'm not sure what's going on. I think my Unreal just crashed. Let's see. Okay. Okay. I'm gonna have to restart Unreal because it just crashed. So I can't work with that big mesh while streaming. All right, just restart. Yeah, I'm gonna relaunch again, and I'm just gonna use the base file or like this workshop file that I sent you guys because that one has a smaller mesh, and then we'll just run through that one. I can't do anything kind of like real time because while streaming it crashes. Okay. Just gonna open it again. Okay, so I'm gonna go back. I'm gonna like start my level. So a neural level. Okay. Okay, so let's see if it works again. Let's go to this one. So let's just try this. I already have these pre-made. Let me see, open them, and I'll drop them in to see if they work on this level. So if you double click on, if you go to Niagara folder and go to 0, 1 simple burst, this is just going to be particles that are going to be spawning from vertices or from the mesh that we input. And then it's going to sample the texture from that mesh. And then it's going to set the particle colors based on that texture. And then we can add some forces to it. So if I open it up here, okay. So this is from that mesh that I sampled, so you can kind of see it. Right. So it's, you can see it like starts from like the mesh. It'll sample the particles from it, and then it'll based on forces, it'll start moving. So this is like very nice and simple to make, and I'll show you how to do it from scratch right now. So if I go to here, and then I'll right click and let's try again, Niagara system. Okay, so now it works. Pick a starting point for your system. There's like a few options here. So new system from selected emitter. So if you already have an emitter created, but you can do new system from a template or behavior example. So we can do this one. Oops. Yeah, is the as the emitter. So if you go to the emitter, they already have like these samples, kind of like preset for you. So blowing particles, confetti burst, directional burst, um, dynamic beam, empty, fountain, hanging particles, omnidirectional, recycled particles in view, so on and so forth. So we're gonna do a simple sprite burst. So if you double click on this, it'll add it here and then finish. And then I'm just gonna call it just gonna give it another name. So like a simple burst. Okay, and then you double click on it, it pops this. So right now it's just kind of like doing one particle at a time, right? Like in this showing it like that. Um, so some just like real quick important facts. So this is your emitter. So this is kind of like where everything lives for the particle. So this is where you would control it. And then you have these properties here. So if you go to these properties, It has local space, but what we really care is the simulation target. So we'll change it to GPU, and then it throws an error here, because it can't have dynamic bounds. It has to be fixed. So we set it to fixed, and the error goes away. So that should be good. And then if we go down here, you can go to the emitter state. So an emitter update is like where these kind of like the settings for creating like the particles, the general overall features of the particles. Particle spawn is how the particles get initialized, like where are they being initialized from, what attributes are they going to be initialized with. So that's kind of where you would instantiate like the mesh and like sample the texture. And then particle update is kind of like where now you would apply different forces to the particles. So how would the particles update essentially when you apply those forces? So what we can do now is, okay, we have the emitter state here set up. This is under self, so this is good. And then it says inactive response, complete let particles finish, then kill. Okay, and then loop behavior. Once we can change this to infinite, so it would run infinitely. And then loop duration. So this is how long it would kind of like go through, like it restarts. That this is like 2 seconds. I'm gonna set it. Let's see, let me do 20 to see how it goes. Okay. Okay, spur burst instantaneous. So this is like how many particles is gonna shoot up at one time. So if I increase this, so this is gonna depend on your computer too. So 1,000, maybe 10,000, right? So it's gonna be spawning like 1,000 at one shot. There's another option here that is called spawn rate. And in order, you can turn this one off by clicking it off so we can see what spawn rate does. And this one, you just have to increase it. Let's say I'm gonna do 10. So it's gonna be popping them in and out, like a particle every 10, right? Okay, so see 1 second, so every 1 second is gonna spawn a new particle. So this one's a little bit different. Spawn burst instantaneous is like you generate a whole bunch of particles at once. This one, spawn rate is like it'll generate a particle at this time, at this rate. Okay, so I'm gonna go through and keep this one for now, with 10,000 particles. Okay, so now we're gonna go to the particle spawn. So where are these particles spawning from? And then one thing that you can see is like there's this timeline at the bottom, and it'll like show you kind of like how it's working. You can like pause this so it doesn't take computation. I usually do that. And then okay, see if it shows. It doesn't show the blue, but usually it shows like also like the blue color should be like the time that is like kind of like taken to run this loop. So I did it pretty small, so it doesn't show it. Let me see. Oh, okay, it's like going up to the. All right. Okay, so now we go to particle spawn. And this is kind of like the part where you're gonna instantiate your mesh. So let's go here. So initialize particle. This is like your lifetime mode. So like how long does the particle last, right? You can change this. You can change this to random, and then it'll give you oops. You can change this to random, and it'll give you a lifetime min and a lifetime max. So you can change this, like let's say I make it like 10, and then this is, I don't know, we could do like 5, right? So they live a little bit. Color, you can keep that as is. I mean, not to set much to it. Also under sprite attributes, this is for your renderer. So the sprite is kind of like this. It's like a material. That is like a plane. It's like a plane that has a material on it, and it it's viewable from the camera angle. So like it'll line up with your camera. So it produces kind of like the illusion that it's round or like flat or like a cube or something like that, but it's just like a material. It doesn't include any like mesh geometry. And I tried doing like mesh geometry. You can go here to render and change it to mesh render. But for when you're going to generate a whole bunch of like, hundreds of thousands of particles, it starts to get like really heavy. So it's usually a little bit better to work kind of with these sprites. So if you go here to sprite attributes and you go to sprite size mode, uniform, sprite size, so you can keep it as like this size, or you can also like change it to random. What is it? Random uniform. And you can also set like a size limit, right? Size min, size max. And then it's gonna like spawn them randomly, essentially with random sizes and random lifetimes. You can also do that for rotation in UV mode, but I think this should be fine. Okay, and then so now we have the particles. We have like spawn versus instantaneous, and we set the loop to infinite. So it's gonna keep going. Once you have that, then now we gotta figure out from where we're gonna spawn these particles. So we're gonna click on this plus here on the particle spawn, and we're gonna type in static mesh, or it's already popping up here. So it says static mesh on their location. Okay, and now it's gonna ask us, there's an error. Oh, okay, so now we need to input our mesh, the FBX file into here, into these two. So if we go to our content drawer, and just grab this mesh here and drop it in to here, and then drop it into here. So if you see it now, this is, let me see. So it looks better like that. Okay. So if you see it now, it like spawn particles on the mesh, right? And if I hit play here, so you can see like some particles are fading in and out, and then it fades, and then it'll restart. And then it'll fade, and then it'll restart. So it's like a pulsating effect. Okay. So now that we have the mesh, what we need to do is add color to it. Let me see if there's any other things from here. Okay, I think this should be good for now. Okay, so now we have the mesh. So now we have a location for the particles to spawn. So now we're gonna go sample the mesh texture. So if you go to that plus sign and then you go to sample texture, you can go here now, and then it pops up, and then it says, okay, texture, which texture to sample. Okay, so we have that texture. So we're gonna go to our content drawer, or if you know the name, you can just type it in here, but I'm just gonna drag it. Diffuse mask texture. Okay. And then where it says texture UV, you're gonna hit this here, this arrow down, and we need to tell it from where. Static mesh location. So we were telling it to sample from the mesh location, which is kind of like the points location on that UV texture. So it's gonna pick the color from like that texture. Okay, so now you can kind of see it. It's a little bit dim. Oh, okay. You can kind of see it, but I think I have too few particles, so you can't really get the effect. So I'm gonna add, wait, let's hope it doesn't crash. and then compile. So once you change something, you can hit compile and then save. So you like save your progress, and then let's see. And there it is. Okay. So now it looks better with more particles. And then you can see like it starts and then it fades. Okay, so now that we have the texture, we already have the color set up. Okay, so now what we can do is we can go down to the forces. So particle update. Actually, I think I need to add something here. Let's just see color. Okay, so you can do this, like you can add this color here, and then change it to sample texture. That should be fine. Okay, there it is. And if I test out the other one, the random spawn rate, so oh, it's only one, so let's do 10,000. Okay, so this one kind of like populates it at a rate. Right? Cool. Okay. So let me go back to the forces and then we'll modify the sprite material. Okay. So now you have this kind of basic setup. You can keep going here to particle update. We already have particle state, scale color. This is like to scale the color based on the update. So like how it dies. And then sold forces. So what we can do here is add a force. So we can go click on the plus and then go to forces. And there's just a few, this curl, noise, drag, gravity, acceleration force, limit force, line attraction force, linear force, mesh rotation, line attraction force. Okay. So you can play around with those. I'm gonna do vortex here to see how it looks. I have to create more particles. Okay, so vortex, I placed it there. And then if okay, so over here, vortex force amount, 200, right? So we can modify that force. And then it's getting the vortex origin, so the particle position. Okay. And then once you have that, let's see, play, and then you can see that it's like rotating it. Right? So that's the vortex. So it starts spinning essentially. Okay. And then we can do something like add drag, so like it slows it down a bit. Um, and then you can set this maybe to 10, rotational drag to 10, and then let's see how it looks. So like it slows it down a bit. So drag is slows the forces a bit, so it looks like a little bit more natural. So that's kind of cool. Um, and it's like a rotate. So it's like rotating and then fading at the same time and then popping out, right? Um, okay. And then another one that we can try. So, now curl noise is cool too. Let me turn on vortex, see what curl noise does. So another thing I forgot to mention, but the way that these I guess like functions within these pieces here work is that you stack them. So like the way that they kind of apply, they apply in like the stack order. So you can like move them up and down. So like you can place drag at the end and then like these forward. So like these calculate and then drag kind of like slows them down. And then the final one, or like the final function is this one here that says solve forces and velocity. And that resolves everything at the end. So everything kind of goes in like top down order. Okay, so there is some, let me try it. One right. Okay, maybe this one better. I'm gonna have to increase the life a bit so it lasts a little bit longer. So file. Okay, so you can kind of like see there is some vortex happening. And I go to particle. So my lifetime is too low. That's why it's like fading too fast. So I'm gonna increase it to 40 seconds. And then 30 seconds. So it's like a random. Then let's increase. I'm just gonna make this a little bit bigger. Let's do 30. It's too big. 20. Okay, cool. So there is the particles. And then I can increase a bit the curl noise. Let me just see if I make it 50. And I can decrease drag of them. So you can see when I decrease drag, like it just starts going. Like it'll look a little bit more random with the curling noise. Yeah. Okay, cool. So that's kind of like the basics, and you can like play around with this a bit, like add more forces. Like you can add, I don't know, gravity. You can add gravity force, a line attraction force, and I'll show the line attraction force in a bit, which is kind of cool, and point attraction force as well. And then point force, spring force, so on. So you can like mess around with these and like try them out and like see how you can modify and tweak this. This is just kind of like to show you like how to set like a basic template for this. And then compile. Once you like if you like this, compile and then save. And then we're gonna check it out in here. So what you can do, there's like one way to do this is like you can kind of just drop it in here, right? Oops. Just gonna center it, center 0, 0. Okay. And if I hit, okay, and here's the particle system. So I don't like this plane too white. So what I'm gonna do is I'm gonna hide the plane. So if I click on the plane, and then I go to let me see. I can just type in here hide hidden, active hidden. So if I go hidden, right, type hidden, I can go to rendering active hidden in game. And this is going to turn off like the plane. So if I go back, now it looks like there's nothing there. And it looks a little bit better so we can actually see the particles. Okay. So like the curl noise, like you can see, it's like it completely dissolves the point cloud. Okay, cool. So I'm gonna take a pause at this part. How are you guys doing? Did you guys were able to follow or get the particle system working? Okay, cool. So let's take another 10-minute break because we're coming up at the last hour. And like I'm just gonna show like a little bit more of an advanced technique to manipulate the particles. So let's take a break and then we'll come back to that and we'll finish with that. Um, so we can come back at 3:12 or well my time, so like in 10 minutes. Okay. So see you guys in 10 minutes then, and we'll be back. Yeah, it's it's heavy, but it's cool. The file should be able to work. Like you have all the sample files so you can test it out later. All right. So we'll be back in 10 minutes, guys. See you. Okay. Okay, guys. So I'm gonna show you few more things that you can do with these particle systems. Walter, can you add multiple Niagara? You mean like to connect them together, or like connect multiple emitters, which is like this one here? I'm not sure what you mean. But yes, you can connect, like you can add another emitter. I'm not gonna show how to do that. Because you would have to like figure out a way to send out information from this emitter to the other one if you want to have like some sort of link. But yeah. Okay. If there's no more questions, I'm gonna multiple emitters, not link. You mean like multiple emitters on the same mesh? Uh, yeah, you can do that. It's just gonna be like really computational and expensive. I don't know. I guess it would depend on like how strong your computer is and how much uh like how many particles and things like that you would add to it. But yes, you can do that. I think that's a little bit more advanced, so I'm not gonna be able to show that. Yeah, exactly. Yeah, you can duplicate. Yeah, exactly. And just add like another. I mean, ideally, you can like place all of these. I don't want to do it because it might crash again, but you can take, for example, all the ones that I have here and just place them in the same place because they all sample the same mesh and it should be able to spawn like a whole bunch of particles, but it would probably crash my computer. Okay, so I'm gonna show a few more things um, that are a little bit more custom. So if you have my the sample files that I sent, so if you go to number 2, which is like this one here, um, so this one uses a different kind of like force and different sort of particle systems renderer, let's say. So one of the things is still the same thing, right? So first burst instantaneous. You can have the static mesh location, same thing, sample color. And then here, what I did is I added this line force. So this line force is kind of really cool. Uh, if I go, let me see if I can do it from here. So if I play this line attraction force, if you put a negative, it expands. So like it pushes out the particle system. And if you make it positive, then it contracts it, which is really cool. It's like 2 effects. Um, and I could do it so this lasts a little bit longer. Okay, so I didn't change the emitter system here, so it's infinite. It just kind of like stops at a certain point. Um, Lifetime is 5, so I could like increase this to maybe like, let's see, 15. So you see that it like kind of contracts with the line attraction force. So essentially what it's doing is like there's like a line here and it's kind of like attracting all the particles to that one line. Um, so if you do that, you can like change the line start here, the line end. You can change the attraction strength. So if you send it to negative, then it repels. If you set it to positive, then it contracts. So I like this one here, that expansion. Let me just try that. And you can modify the line start. So this one is creating a line at the X 100, 0, 0, 0, and then negative 100. So you can, I don't know, see if we modify this to like 50. It's just going to change how the particles are going to be expanding. So So you can play around with this and mess around and see how it looks. And I also added a drag force just to slow it down at 2020, so it doesn't look too crazy. Because if I do that, then it's gonna move really fast, right? Yeah, cool. So that's that, and then there's this component here is called scale color. And what you can do with this component is kind of cool because you can modify how the color fades as it expands, right? So if you go here to scale color, and then you go to let me see if I can do it again. Oh, yeah, curve from vector. So this should be under curve from vector 3. And then what it does, like it pops out this curve, and then you have X, Y, Z. So these are your RGB values. And what you can do is like modify those. So like when it expands, like it'll modify a color. So like you see here how it remains the same color all around. Let's see, it's a play. Yeah, so you see how it like remains the same color all around. What you can do is like tweak this parameter here. So like, for example, if I want a little bit, let me see, blue. So if I start moving these around a bit, like you see like the colors change by time. And you can also do it here with these templates. Like these are kind of like smoother curves, right? So you can like select this one and then it's gonna like modify the colors a bit through time. So that's just something to like, I guess another thing to play around with. See, so like it changes. You can like move the color specifically. Yeah. So that's another thing to change the effect. Um, this is scale alpha, so this is like the particle um transparency. So you can like change this too a bit, right? So like as it gets further and further away, it should be able to get like more transparent. Let's see. Okay. So you can like tweak these from here. The way to get them is like if you go here, um, or like to get these curves so you can like play with them is like you go to this button here, right click, and then you do from curve, like type in from curve, and then you get this, you get vector from curve, so you can change that one. These are dynamic inputs, so you can like modify those. Scale vector by curve, so you can do that too. Main vector from linear. So usually like with these curve ones, you can like modify and like drag them and stuff like that. So you see like the alpha, like when I change the alpha a bit, it like fades out like the particles at towards the end. Okay, and so that was that for this. And let me show you. So if you go here to mesh render, I set a particle cube. So this one is kind of different than the other method that we saw here, the spray render, which is just the default spray material that comes um with Niagara. Uh, this one, it's also particle cube, but we can do something with it where we can like scale it in like directions. Excuse me. So we can take if you don't have this, you can just go here, select under search assets, and then go to particle cube. And then you should pop out here. Okay, so it's already there, so it's not gonna let me change, but it's there. And then we can take a look at it, like we can double click on it and we'll see it. And it's right here. It's a little bit small, but okay. And then you can also change the material here. So if you go to here, to where it says particle cube, and then you double click on this material, it opens up this new tab called material. And then one of the things that's crucial about the particle materials, or like how to, like for example, when we instantiate particles of a mesh and then take the sample of that UV mesh, if you want to create like a different type of material with like different properties, for example, you can change it so it's like less metallic and so on and so forth. You can do it like this. So I'm going to show that, but this component here, particle color, is like important because this one is what's taking the input of the particles. So like all the attributes of the particles being spawned, and then you connect that to the base color, and this is what's gonna allow you to sample from like a UV coordinates on the mesh. And then if you want to change these kind of like parameters here, you can drag from here. Let me see, I can do, oh, let's do a emissive. You can drag from here, and then what's it? Let's parameters. No, it's okay. So if you drag from here, if you drag from this pin here, and then you hit S, it'll create like a parameter. Like you just tap the letter S and click, it'll create this parameter, and then you can modify, like give it a name, like here on the side. Let's see, emissive. I don't know if it's emissive color. And then this should be. Okay, I don't know if this is gonna work, but actually I'm gonna try with an emissive color, but let's see what happens. Apply. You can always delete it. Okay, so too much. So now they're just really bright. They're just being emissive. So we can go back. I'm just gonna delete this one, but you can change the roughness. The roughness. So if you go towards what was it? Point, like if you go low number, let me see, 0.1, it becomes like shiny, reflective. So that's what roughness does. And metallic is just to give it like that metallic look. Roughness changes the reflective look of this. So if I do that and then apply, let's see, and I go back to this. Oh, hopefully it doesn't crash my computer. So you can kind of see it, like it is having like some reflective qualities. It's kind of hard to see it like this, but yeah, you can kind of see the material. So you can modify that part too. Let me go back to this one. That's a little bit more computationally expensive. Okay, so that's how you manipulate the material, but you always gotta have particle color if you want to be able to use it with the particle system. Okay, and then let me exit out of this. Yes. Okay. Should be all of that. Okay. So, and then what you can do with this particle cube is that if you go, once you go here to mesh render, under scale, you can go here to, for example, these scales, no? So like 111 and 20. So I increased it in the Z axis to 20. But you can, do whatever you want. Like you can change it here or here. And let me go back to 10 to see how it looks. Right, so it like makes it a little bit smaller. So you can like modify those properties. You can also do rotations, right? So you can change it if you want it. I don't think it'll show much here. Um, Let me just see if align. Let's see. This one's okay. So if you put, I don't know if it's working too well. I think the mesh has too many. But if you add this method here, oops, fix issue. Okay, if you add this method here, align sprite to mesh orientation, it should be able to like spawn it or spawn the particles. I think in the normal direction of the mesh, so it looks more aligned. But it doesn't look too much because there's so many particles and they're kind of like everywhere. But you can kind of like see here, like some of these are following like the wall up. Right. So you can add this or turn it off and then yeah, doesn't do much. Okay. Um, so that's that for that. So this is like another type of emitter that uses a mesh render, but it uses like the particle cube, and then you can scale the cube. And then also like you can scale the color and mess around with the color and the alpha. So like it modifies when it moves, like how the color changes. Okay. So let me go back. Okay, so that one's good. That one's good. Uh, okay. So this one is a little bit more involved. So I might just finish with this one, this effect. We're coming close. So this one, is like a custom coded effect, where you're kind of like shooting like you're using the line attraction, but you're modifying it in a way where it has like some proximity or area that it would affect, right? So you can kind of like see that it's selecting, like there's this line going across the 3D mesh, but then it's only selecting like those parts from the point cloud, right? So it's not modifying everything. It's only selecting like those. Um, And let's see. So it's like the same thing. So you're going to start with the emitter, spawn burst iterations, and also this particle, sample the mesh, sample the texture. Um, and then you're going to go here. So we're using the particle cube for this, right? But this here is the attraction strength. And this is, let me see. Okay. Now let me, okay. Uh, okay. So this one is like custom code essentially to be able to do that. So I'm just gonna go through this. Like you should have it. It does contain a little bit of math, but should be pretty straightforward. So if I do, for example, attraction stem 200 and the threshold. So the threshold is, I can decrease it, and then the portion being affected is smaller, right? You can kind of see like it doesn't pull from above anymore. It's just kind of like yeah, it's like a smaller particle. You can increase the strength. So let me do like, I don't know, 2000, see what happens. Like, So you see how fast like that moves? It like literally went out. Blue by. And then 500. Yeah. Yeah, so that takes a larger portion of the mesh. Let me just sense it. Okay. And then you can modify the line again, like you want to do that. I'm just gonna bring it back down to 400. So it's like a little bit smoother. You can also add drag to this if you wanted to, so like it looks a little bit, so it doesn't go too hard. Let's see, drag. I'll do like 10. Yeah, so it's like maybe too slow. Yeah, so there it is. So something like that. That's cool. It takes a portion of the mesh and just completely squishes it to a point. And then compile, save. Okay. So let's go back to that code real quick and I'll explain how it works. So if you go here, this should already be saved within the script here. If I go to blueprint, no. It's not open it from here. Okay, if you go to line attraction of force with threshold and you double click it, right, it's gonna pop out this code. So this is essentially like a graph, a code graph of the particle system, and it's based on the line attraction force that I showed previously, except like we're doing like a few modifications, so it does kind of like that pull close effect. And I'm gonna go through it because it's simple math, it's just vector math, but essentially what it's doing here is it's gonna take the particle's position. So if you start from here, right, this is pretty standard, and you can find these graphs. Let me just show what this graph is, and then I'll go through it. If you go to, so here's the script, but if you go to started content, let me see. Let me see. Line attraction was engine. So this is kind of like what makes Unreal work. So I wouldn't touch this, but you can find the scripts for these forces here under plugins, engine plugins. And then if you go down to Niagara content, and it was under, I don't remember what it was. No. I don't remember where. Okay, I don't remember where I found. Okay, but anyways, so that was it should be somewhere here under plugins and Niagara content. Just don't remember which inside of which folder. Let me go back to where I was. Niagara. Okay, and then what I did is like I copied that script from the engine content and then just modified it here. And then what it does is like it takes that attraction force, the line force, so it's gonna get a line. So the line start, the line end, and this is like the parameter that you input in the the Niagara panel. That is going to take that point to line, segment distance. So essentially building like the line, and then it's going to build like a fall off. So based on that distance and the start and end position is going to multiply that and calculate like what is the fall off rate. And then it's gonna custom vector, the texture is not showing in custom vector. In custom vector for this one, you said it's not showing. Does it have the sample, the mesh sampler? So you have to have the triangle, the sample texture, and then on the texture UV, it should be a static mesh location, right? And then your essentially is your mesh render that should have this. So if you go here, the mesh render material should have this particle color attached to it. Then you can apply and save. Should be good. File, save. So that should be it. I'm not sure like what would be the issue, but it should be working like that. Okay. So let me just go back to this. So and then this is kind of like the part up here that is kind of like standard from Niagara. So this code is already done. What it's doing here, what was modified, is that we're gonna grab the position of this particle system. We're gonna calculate this vector here to like push it. So it's doing something like this. Let me annotate. So what it's gonna end up doing is that, let me see if I can draw it here. Okay, how to make it bigger. Okay, so what it's doing is going to be something like this, where you have a vector, and then you have a particle here, and then here's your other vector. You're calculating this distance here. So this is like vector map. I'm not gonna get too much into it because it's like a little bit mathy, but you have kind of like essentially you're trying to find these vectors by adding them up. So this kind of, by using these kind of vectors, you can get to like a position, and then you get like a length at the end that essentially tells the particles like how to move at that point. So when they get to here. So ideally you have, this is your A vector, this is as here, start, then end. And then, so what you're doing is you're trying to calculate this position here. So right, this is your A vector, and you have to subtract the lines, the start and end lines in the position vector here, which is this one here. This is P. And then you're gonna go through it. You're gonna normalize this L vector. The L vector is the overall length of like this one here. So you're kind of building like a triangle out of these particles. And then okay. And then once you do that, like you're summing up, you're subtracting these vectors to get like the other remaining vectors. You normalize this, and then that's gonna give you another vector that you multiply for scale. And then once you have that, you get the length of that vector, and that tells you like the direction where it's going. Then finally, there's like a threshold, which just kind of tells you, okay, if it's like this length is smaller or greater than that, then get rid of those particles or like select those points. If not, then apply just the regular physics force, and then it'll pass out to the physics force, and then it'll output in math. So this is a little bit of a vector math, but I just wanted to show this because you can kind of essentially open up these systems or these particle systems, and if you know how to do the vector math to deploy like different types of movement and attractions, like you can do things more complicated and essentially build like more complicated simulations of these particles, just doing like basics vector math. And then you can add like thresholds or parameters to be able to essentially generate like the effect that you want. And so that's pretty much it. So I don't know. So like you get this, right? So it's going through the line and then it's pushing what I was saying is like it's grabbing like these. Let me see if I can write it here, but so it's going like this. It's calculating this direction based on like the point position, right? And you're trying to find out where it's going. And then this, you're gonna get the length here of the distance between like where the particle is and that line. And then once you have that distance, let's say, that's kind of like the area that gets affected in the simulation. Or like that gets oops. So if I play it again, so you see like it's moving towards like this point. This is probably easier to see. So like you're calculating this direction with those vectors based on where the particle is located. So the particle's here, you're trying to have the particle kind of track along this vector and then get to like a point. And if the particle is within a certain bounds, uh, so if this is, I think, what was my threshold? 500, right? 500. So this is my threshold. If this particle is within this bounds from this line, from this distance, then it's gonna grab it and leave everything else untouched. So that's kind of like, I mean, it's basic. It's like vector map, but like you can experiment with those more if you want, and test it out and like produce more complex simulations. Uh, okay. Okay, so let me see what else. Have anything else left? Okay, and I don't have time to show this, but this is essentially like the same thing here, uh, except that it's not showing. Second, we just this one is similar, except that it just has a little bit more things, like more forces attached to it. But it's kind of like using that line attraction force field and then adding like you can't really see it, but adding like more forces onto it, so it like produces like an more interesting effect. And if I drop it in here, well, it's a little bit messy there, but let's see. I can't really see, it's too small. Oh, you can kind of see it there. It's going crazy. My glare disappeared. Let me drop this one. So you can kind of see that's the other vector where it's like moving. It's like taking a piece of it and essentially pushing it towards like a point, following a line. Okay. So yeah, okay, so I think that's pretty much for the Unreal part. So you should be able to use those scripts to play around. Yeah, so you can, and now I'm inside of it. Okay, cool. And that's how you can get these cool particle animations with Unreal. All right, cool. Questions. Okay, so what if we want to simulate landscapes? How do we adjust the Colab file? Do you mean like to generate like a 3D mesh of a landscape? Um, it's really not set up for landscapes. I mean, you can probably just change the prompt, but it was mostly set up for like type of like architectural buildings, like interiors and things like that. But you can probably change the prompt and just see like what you get. Like, could be interesting. And the way to edit that, and I'll go back to it real quick. Uh, uh, if you open up that JSON file that I showed earlier, you can just edit the prompts directly. So maybe like if you wanted to like simulate, what's going on? I think my Google Colab crashed out. So let me do it this way. Yeah, if you wanna like do it so it's like you can go to like its trajectories examples and there should be JSON files there, and then you can just go in and edit like the prompts for them, and you can test it out with like landscapes and see what you get. Like I haven't tried that myself, so it could be interesting. But yeah, that's kind of like one way to go about it. Okay, cool. That's all I have, guys. So we're close to like the hour here. If you have any more questions, or if not, I think I'm done, Michael. Uh, yeah, if your Colab is crashing, it's probably because it's running. Like if you get it to run, it's probably just running. You have to wait till it finishes. Like mine finished, but it took about, I don't know, like an hour or so. Um, like this is how many seconds it took to create, 722 seconds. But it'll come back to normal once it's done. Cool. Thank you guys. Thank you guys. Appreciate it. If you have any questions, just reach out to me on Instagram. I think Michael posted like the the handle.
Thank you so much, Daniel, for this awesome webinar. This is really cool. Uh, Seems everyone enjoyed it. And with minimal technical difficulty from AI.
Yeah, just one.
Yeah,
Took 10 minutes to fix, thank God.
yeah. So that's always good. Thank
Yeah.
you everyone for joining. Just a reminder, we also have two webinars next weekend. Um, I would say if you enjoyed this webinar, you should definitely check out the brainstorm simulation next weekend, which is also you making 3D spaces with AI in a different way. So if you enjoyed this one, that one I think would definitely be of interest to you, the brainstorm simulation, which is next Sunday. So definitely go give that a check out. Um, as always, afterwards, the recording will be emailed. Once the Zoom processes it, you'll get an email to view it. And thank you everyone for joining and following along.
Awesome. Yeah, thank you guys, and thank you, Michael. It was a good time.
Yeah, thank you. Okay, until next time. See ya.
See you guys.